modern airliners are among the most complex and reliable machines in common use. But occasionally, delays in fixing a known defect have led to disaster. This is the story of one of the most terrifying and avoidable accidents in recent history. When a 747 suffered a devastating explosion at high altitude, the crew and passengers faced an unprecedented crisis. It is also a story of how one family's grief led to a relentless investigation to uncover the full, disturbing truth.
Lee can't have died for nothing. You know, you've got to find out why he died, and you've just got to make sure that it never happens again.
And it reveals how other known problems in aircraft design have continued to go uncorrected, causing further avoidable accidents.
So would I be surprised if it happened again? I would be surprised if it didn't happen again. It is a matter of time.
One of the most shocking cases of a known design flaw being ignored for years would finally take its toll on a United Airlines 747 bound from Honolulu to Auckland, New Zealand. As Flight 811 prepared for takeoff, the crew were concerned with another kind of threat that had recently led to tragedy.
We were in the aftermath of Lockerbie, and I had instructed the crew to be particularly aware because it was a through flight from Los Angeles going through to New Zealand. So in my pre-flight briefing, I had asked them to make sure that they checked any baggage that looked suspicious or anything because we wanted to be extra cautious.
Flight 811 was heavily loaded, 337 passengers, packed cargo holds, and a full fuel load. The doors closed on time, and the plane left the gate just before 2 o'clock in the morning for a routine 8-hour flight.
Well, we were going to New Zealand on vacation, someplace that we had really thought was interesting, and somebody had told us how beautiful it was, so this was kind of a dream come true.
I was seated in what's called the upper deck. I hadn't had a vacation in 5 years, and I took all my Mileage Plus points from United Airlines, and I purchased a business class ticket to Auckland, New Zealand, and Sydney, Australia. I was going to finally make that dream vacation I'd always wanted, to get to Australia and lay on a beach somewhere and forget about airplanes, forget about accidents, and get this out of my mind for a while.
On the flight deck, Captain Dave Cronin was hugely experienced, just 2 months short of retirement.
Rotate. I flew almost 35 years with United. I've got over 30,000 hours of flight time and just about everything, military as well as civilian. My co-pilot, or first officer, was Al Slater. And I've known Al at that time for probably 20 years. And the second officer, Mark Thomas, was the first time I had flown with him. But we got along real well.
Tell them we can handle 33 if it's available. Okay.
The pilots wanted to climb to 33,000 feet above the Pacific Ocean to avoid turbulence from bad weather.
We did notice that there were thunderstorms 100 miles south, right on course, which was rather unusual for that time of night. So I left the seatbelt sign on.
Captain Cronin's decision to keep people fastened in their seats would save the lives of many.
We were still climbing out, and the seatbelt sign was still on, and just basically getting ready to serve beverages and then to tuck everyone in for the evening because it was going to be a long flight down to New Zealand.
Okay, tell them we're going to detour over to the left.
Center, United 811 Heavy, we're going to be detouring. Some weather here, it'll be to the left, of course.
100 miles from Honolulu, As Flight 811 climbed through 23,000 feet, a critical malfunction was about to occur. There was now a huge air pressure difference between the inside and outside of the aircraft. Suddenly, passengers sitting just above and behind the cargo door heard a noise.
Then there was kind of a grinding noise.
I heard like a thud.
The hell?
In the next nanosecond, it was pure, unadulterated pandemonium.
We lost number 3. Going down.
It looks like we've lost number 3 engine and we're descending rapidly. Coming back.
The next thing I knew, I found myself on the stairwell, hanging onto the rungs, and I immediately knew it was an explosive decompression.
The cargo door had torn off and ripped a huge section of the plane with it. The pressurized air inside blasted out with explosive force.
I immediately thought of Lockerbie. We actually thought it was a bomb that went off.
It was hell on earth. Everything on the airplane that wasn't fastened down, tied down, or secured became airborne. The noise was incredible.
Everything in front of us was gone. Where we were sitting, we were about 6 inches from the hole, so there was nothing in front of us or to the side of us. The whole side of the plane was gone. Actually, our feet were dangling on the hole, and I first thought we weren't going to make it. You know, I just didn't think there was any hope.
With the pressurized air blown out, the lack of oxygen at 23,000 feet was now suffocating the passengers and crew.
It felt like someone had kicked me in the stomach, knocked the wind out of me. And I remember trying to catch my breath and couldn't. You were supposed to grab those oxygen masks and put them on, except the oxygen masks in that cabin, they were ripped out of the ceiling and they weren't there. And I remember thinking to myself, this is what it feels like to suffocate.
United 811 Heavy, we're doing an emergency descent.
The pilots could tell from their instruments that the number 3 engine was failing, but they couldn't tell the full extent of the damage. Their priority was to get the plane down to a level where they could breathe normally.
Put your mask on, Dave.
But the pilots didn't know that the explosion had destroyed the entire oxygen supply.
Can't get any oxygen.
We're not getting any oxygen. You getting any?
I can't get any either.
With the plane heading steeply down and no word from the cockpit, the cabin crew feared the worst.
I remember thinking that the cockpit, which is up in the upper deck, had probably blown off the airplane too, because as far up as we could see, there was nothing there.
Now we're doing this nosedive. My next thought was, oh my God, we're just going straight down. We're going to crash into the sea.
With its airframe ruptured, severe damage to the right wing and engines, and the crew forcing it down in an emergency descent, the problems on Flight 811 had only just begun. Two minutes after suffering a devastating explosive decompression, Flight 811 was still in a steep emergency descent, passing rapidly through 15,000 feet to reach breathable air.
United 811 Heavy, say your altitude now.
Leaving 15.
United 811 Heavy, we're out of 15.5.
United 11, roger.
I think we blew a door or something.
Tell a flight attendant to get prepared for an evacuation.
The crew finally began to level out at a safer altitude, but they now faced a barrage of problems. The most immediate was the disintegration of the number 3 engine, nearest to the explosion.
We don't have any fire indications? I don't have anything. Okay, we lost number 3. Let's shut it down. There's no M1.
Yeah, okay. Ready for number 3 shutdown checklist.
Number 3. Before you shut down number 3, the generator went off. Looks all right to try it now.
Well, let's stop the vibration anyway.
Fuel jettison procedure. Main boost pumps. On.
Center, United 811. We need the equipment standing by. Company notified, please.
We got a control problem.
Roger.
Center wing. Left, right. Valves. On.
Start dumping the fuel.
I am dumping.
One stewardess had been seriously injured by falling debris. As Laura Brentlinger helped her, the full gravity of their situation suddenly became clear.
As I'm holding her in my arms, I looked up, and as I looked up, that was the first time I saw this tremendous hole on the side of the aircraft that was just a void, and seats were missing, and I immediately knew that we had lost passengers.
5 rows of seats had been blown out in the decompression, killing 9 passengers. On the flight deck, the crew had turned the stricken plane back to Honolulu, but with 80 miles still to go, the crisis now got far worse.
We got a hell of a control problem here. I got almost full rudder on this thing.
Are you dumping as fast as you can?
I'm dumping everything.
We got a problem with number 4 engine?
Yeah.
Debris from the explosion had also damaged the number 4 engine. If it failed completely, the implications were severe.
If you're on 2 engines and you weigh 700,000 pounds, that is a big deal. Simply because with that kind of weight, 2 engines are not going to keep you in the air. You're going to come down.
Can you maintain 240?
Yeah, just barely.
We're losing altitude.
Know it.
Center, United 811 Heavy. Do you have a fix on us?
Affirmative, sir. I have you on radar.
Okay, we've lost engine number 3, and we don't have full power on engine number 4. We can't hold altitude right now. We're dumping fuel, so...
United 811 Heavy, roger. I show you 60 miles south of Honolulu at this time.
Roger.
I haven't talked to anybody yet. I can't get to him. You want me to go downstairs and take a look?
Yeah, let's see what's happening down there.
I think we lost a compressor, but...
Can't hold altitude.
Yeah, I told him that we're
Put
gonna...
some max on there. I got takeoff power on this thing.
Whatever you need, Captain.
Although the number 4 engine was failing, the pilots pushed it, along with the remaining engines, to full power, a setting they should not be run at for more than 4 minutes. But the nearest land was 15 minutes away.
I look out the window on the right-hand side, and I see flames, big flames. And I know what flames in an engine means. It's not good.
The pilots were unaware that the number 4 engine was now on fire.
You got 250 knots now, that's good. 7,000...
Yeah, we're getting more rumble.
Watch your heading, watch your heading. You want to go direct Honolulu.
Okay, I'm going to go downstairs and see what the hell is going on.
Yeah.
Go ahead and run down and see what's happening.
I saw the flight engineer descend down the stairwell. And when I saw him, my relief was, oh my God, they're alive. And there was a huge sense of relief for me. He saw the hole, turned as white as a sheet, and I screamed to him, dear God, please get us down.
We've got a fire out there.
Oh yeah, we got a fire in number 4. Go through the procedure. Shut down the engine.
We're not going to be able to hold this altitude on 2.
We got a fire on the right side. We're on 2 engines now.
The whole right side, it's just gone from about the one right back to it's just open. You're just looking outside.
What do you mean?
It looks like a bomb.
Fuselage?
Yeah, the fuselage, it's just open.
Okay, it looks like we got a bomb that went off on the right side. The whole right side is gone.
Yeah, from about the one right back to,
Anybody?
some people are probably gone. I don't know.
I knew that we had lost people. I didn't know how many. In fact, I didn't know until the next day how many were lost. But, you know, it's a terrible thing when you're a captain of an airplane and you lose passengers.
Lee Campbell, flying home to New Zealand, was sitting in row 10, just in front of the cargo door.
I woke up with such a start because I'd seen Lee standing by the bed, just with a grey jacket over his arm and a small smile on his face. And of course, as I woke up, it faded, wasn't there. And then we woke up in the morning, we discussed this. I said, oh, that was strange in the night, but it was such a vivid dream. Lee was standing there. And then the radio came on, and the first item of news is that there'd been a problem with the United aircraft. And I said, that was Lee, that's Lee's. And my blood just ran cold. I knew he was dead from that moment.
Center, do you read? We evidently had a bomb or something. A big section of the right side of the airplane is missing.
United 11 Heavy, roger.
I wouldn't go any faster than I had to because that hole, I mean, I wouldn't get it over 250 knots because that's a big...
Okay, what's our stall speed?
I wouldn't go below 240.
Yeah.
I don't know if we're gonna make this.
We didn't know that we were going to make it back. So we were actually preparing to ditch that airplane at night in the Pacific Ocean, which has never been done before.
In the cabin, the crew prepared for the worst.
My training kicked in and got up from my jump seat and started instructing the crew. We have to prepare the cabin. We have to, prepare for a ditching, which I thought was inevitable.
You're running around getting life vests on, and I do remember thinking, I'm not sure this is going to matter, because when we hit the water, I just imagine the plane's going to split apart.
I knew that if we hit the water, it'd be tantamount to hitting the ground, and there would be very few, if any, survivors. So my mind went to the things that meant something to me, and at that point in my life, it was my son.
Believing they were going to die, one passenger took these photographs in the hope they'd be found in the wreckage and give clues to the cause of the crash. For 15 minutes, the plane steadily lost altitude. Then, at 4,000 feet, the first glimmer of hope.
After an imponderable time, I remember one of the passengers began to point out one of the windows on the right side. And everybody looked. And we looked through this little window from wherever we were, and we could see a point of light, and another point of light, and another point. And pretty soon, you could make out a coastline.
Okay, I got lights over here.
Okay.
Okay, we're at 4. We're 21 miles out. We're in good shape.
At Honolulu Airport, an emergency was declared. All other aircraft were diverted, and the rescue services prepared for the crash landing of a fully loaded airliner.
Hey, you want to give me some speeds?
Yeah, 150 is going to be your 2-engine. Use a 160.
I need souls on board if you have it.
Okay, souls on board.
160 is the minimum.
Stand by, United 811 Heavy.
I don't know how many's on board. 200 and... I don't have the paperwork in front of me here.
We're too busy right now. 200 and something.
Okay.
6 minutes from the airport, the crew now had to slow the overweight plane for landing. But the effect of this was unknown.
What's going to happen when I start coming out with flaps and landing gear? We're either going to land on the airport, in the water, or downtown Honolulu.
Okay, we'll try 10. Okay, inboards are coming to 10. How do the controls feel?
All right so far.
But the flaps were damaged and could not fully extend. This meant that Flight 811 would have to land dangerously fast.
United 811 Heavy, do you have the airport in sight?
It's over here to the right, Captain.
Okay.
Okay, we have the airport. United 811 Heavy.
811 is clear to land 8 left. Equipment standing by. Wind 05012.
clear to land. 8 left, United 811 Heavy.
As the unstable 747 lined up for landing, the pilots knew they would only have one attempt. But even if they got it on the runway, the nagging question remained. Would the stress of impact cause the damaged and overweight aircraft to disintegrate? Severely damaged, with an unstable airframe and losing altitude on just 2 engines, Flight 811 now began its final approach to Honolulu Airport.
2-engine approach.
2-engine approach.
We still had no idea how far off the ground we were, if we were going to make it to Honolulu or not. But that seemed like an appropriate time. If we were somewhere around land, that we're probably going to try and land somewhere to get the passengers in their brace positions. So that's when we started yelling for them to get down in their brace positions.
Every molecule in my body combined to express, get this damn airplane on the ground.
Well, how are we doing on the hydraulics?
Hydraulics are good.
You got brakes?
Normal hydraulics.
So we got brakes, but you're only going to have reversing on 1 and 2.
Though I thought maybe there was a chance that we were going to actually be able to attempt to land, the thought came to my mind, what happens now? Do we, on impact, do we explode? Do we fall out this huge hole?
Despite dumping fuel, the aircraft was still critically overweight. But without full flaps to keep it in the air, it had to approach fast.
1,000 down.
The danger was that the undercarriage could shear off and the plane break up.
1.5 high. 190. 185. A little slow, Dave. It's below what we want. Coming up on the glide slope.
Okay. Well, let's try the gear.
No one knew if the explosion had damaged the landing gear.
I remember Laura saying to me that she didn't hear the landing gear go down. And it was loud, you know, it was still loud, and I didn't hear the landing gear go down. So that's another thought. Maybe they can't get the landing gear down. Maybe it's not down.
Got gear down, we're clear to land, and everything's taken care of as far as we know. $200. 195. Half a dot high. Looking good. 192. 195.
Coming off on the power.
100 feet. 50 feet.
Center the trim. Center the trim.
30. 10. 0.
We're on.
Gear's holding.
We landed. It felt fast. And that was my next concern, is that we weren't going to stop at the end of the runway, that we were just going to keep going.
And all of a sudden, we were slowing down, and I said, "Oh my God, we've landed. We're on ground." And the people started applauding.
Probably the best landing I've ever made. When we finally stopped on the runway, We deployed all 10 chutes, and the flight attendants evacuated all the passengers.
It's amazing how fast everyone went. My understanding is like less than 45 seconds, 330 people were off the airplane.
We were probably 20 feet off the ground, and I would have stepped out of the airplane without a slide. I wanted to get off so bad. Fortunately, there was a slide. I stepped into the abyss, fell into the slide, whooshed down to the bottom of the thing, and then you hit feet running.
The slide kind of kicked me up and flew me up into the air, and my thought was, oh my God, I'm going to survive this whole thing, and I'm going to get wiped out here on the evacuation, because it just really threw me. And I landed and scraped up my legs pretty badly and landed on my feet, and it wasn't until that moment that I had the sense of, I'm here, I'm okay, I'm on the ground.
When we got all our switches off, I ran through the airplane, made sure there was no one else on the airplane, came up to the door 1 left, and went down the slide, and I came around the front and I saw that humongous hole in the side, and I just couldn't believe it. By the grace of God, we made it, and it was an awesome experience. I would never want to go through that again.
It was crazy, it was wild, it was scary, all at the same time. I just thought that was the end, that we were going to die. I mean, that was my first thought, that this is the end.
But for the families of the 9 people who were killed, the ordeal was only beginning. Kevin and Susan Campbell's son Lee had been flying home.
About 3 o'clock in the afternoon, I think they said that there was no New Zealanders involved, but we just knew that it was Lee. And then about, I suppose, a quarter of an hour later, we got a phone call from Chicago, and they just said that they regret to inform us that our son was missing, presumed dead. And I guess about another hour after that, a policeman arrived at the door, and he took one look at us and he says, "I can see that you've had the news." So it was just an awful, awful day. And it certainly didn't get much better for a long, long time.
Although Lee's body had not been recovered, the Campbells flew straight to the wrecked aircraft in Honolulu.
Your initial feeling is that you want to be as close to the spot where your relative died, and that was the aircraft. So we had to immediately go in and see the aircraft.
The damage inside was horrific, just a total mess. And the hole in the side of the aircraft was much bigger than I had thought it would be, even though we had seen television newsreel reports. And it was so sad to get in and actually see where Lee's seat had been. The legs of the seat were still there. There was a good bit of fuselage beside him, and still a window.
But the Campbells' desire to find the cause of Lee's death inevitably brought them face to face with dreadful details.
They took us to the medical examiner's office as well, because they had found body parts and that sort of thing. So they didn't actually show us the body parts, but they showed us bits and pieces that they had recovered from the engines, and we got the medical examiner's report on what they had recovered. So, we really would have preferred that it was Lee that went through the engine, because it would have been an immediate death, whereas it was a 4-minute fall down to the ocean, and we know that the people could have been alive as they were falling. And when you think about that, that's just horrific.
As it became clear that their son's body would never be found, the Campbells' need to find the cause of the accident that killed him grew stronger.
Lee can't have died for nothing. You know, you've got to find out why he died, and you've just got to make sure that it never happens again.
The Campbells embarked on a relentless personal investigation that would last nearly 2 years. The loss of their son meant they would stop at nothing to uncover the truth.
The engines number 3 and 4.
2 months after the accident on Flight 811, when the National Transportation Safety Board held preliminary hearings, the Campbells made sure they were there. But they soon grew frustrated. The NTSB would not complete its report for months, so the Campbells took matters into their own hands.
We certainly weren't going to leave it to the NTSB to come up with the findings. We were going to follow through. And when the hearings ended, they had said that we could take whatever we wanted off the press table. And Susan walked up to the top table and yelled out, "There's a really good setup here." So grabbed a box and loaded in all of the documents that we could find up there.
Kevin's the most honest of people I know, but here he was taking something that we hadn't specifically been told we could take.
And we're heading out the door just as the NTSB were arriving back in with the trolley to pick up all their documents. So we were out the door and into a taxi and gone.
So we quickly realised we'd got a really good set of papers with a lot of things that hadn't been released to the public. We were able to really start our investigation in earnest at that stage.
The unpublished documents revealed a disturbing catalogue of problems with the forward cargo door, going right back to its original design. Instead of a plug door that gets jammed into its frame as the aircraft pressurizes, Boeing opted for an outward opening door. This allowed for more cargo space, but was not fail-safe like the plug design. So Boeing built what they believed was a foolproof locking mechanism.
What they do is they build in multiple redundancies to make sure the door is properly latched and does not open. And you build it in to a point of that it's extremely improbable that the door would ever open.
So what went wrong on Flight 811? The Campbells soon discovered that the problem lay in the design of the locking mechanism. To lock the cargo door on the 747, electric motors rotate C-shaped latches around pins in the door frame. A handle then moves arms, known as locking sectors, over the top of the C latches to prevent them from reopening. But as early as 1975, problems were found with the locking sectors. Kevin Campbell, an engineer by training, built a model to show the weakness in the Boeing design.
Initially, the locking sectors were made in aluminium, and in 1975, Boeing realised that they weren't strong enough, and they actually doubled up the aluminium to make it double thickness. But it still wasn't strong enough, and a lot of the airlines didn't even put the doublers on anyway.
The weakness of the aluminium drastically increased the risk of the door accidentally opening.
With the aluminium locking sectors, if the C-locks tried to backwind, open electrically, it would just push the locking sector out of the way. It just simply wasn't up to the job that it was designed for.
For 20 years, 747s have been flying with this crucial weakness. The Campbells wondered what else remained to be revealed. They redoubled their efforts to uncover the full truth behind the accident that had killed their son.
We bought a car and set off in the United States to see as many people who were involved with the accident as possible. We started at Seattle, down to Denver, across to Chicago, through to Washington, D.C., down to Kentucky, on to Miami, and back across to San Diego, back up through San Francisco, back to Seattle. And that was just one trip.
The Campbells soon found that a shockingly similar incident to Flight 811 had given clear warnings of the dangers in the cargo door. In 1987, 2 years before Flight 811, a Pan Am 747 had been climbing out of Heathrow when it failed to pressurize at 20,000 feet. The pilots had to turn back.
When they got back to Heathrow, they found that the door was hanging open 1.5 inches at the bottom, and all of the locks were open. When it got to the maintenance base, they found that all of the locking sectors were either bent or broken.
Why had the sea latches turned and bent back the locking sectors? Boeing claimed that the ground crew must have mishandled the mechanism.
The door had been closed manually, and what they said happened was that the guy wound the sea locks closed, 98 turns of a speed wrench. He closed the outer handle and then wound it open again. And if to be in the position that they were found in when the aircraft got back, he would have had to wind them open 98 turns. And this is just absolutely ridiculous.
But the Campbells' investigation uncovered another vital clue to why the sea latches had turned. A report by Pan Am engineers highlighted problems with the door's electrical system.
It had a fault in the S2 master latch lock switch that should have turned off the power to the door when the outer handle was closed.
This was an alarming finding. When the outer handle was closed, the S2 master lock switch was meant to disconnect the power supply and stop the sea latch motors from turning. So could this have failed, allowing the motors to open the door? To find out, Boeing asked the airlines to do a simple test. Close the outer handle, then press the switch to open the door, and see what happens.
When they hit the switch, it actually worked. The Boeing thought, you know, this is not going to work, but it actually worked. There was power to the door locks with the outer handle closed, and the lock started to move, and it started to force the locking sectors out of the way. And a few days later, the airline started ringing in and saying it was damaging their planes. So Boeing stopped the test. But it meant that on those aircraft, the S2 switch had failed, which is a silent failure. And all of those aircraft were likely to have the same problem as 811. They were just waiting for a short circuit to open the doors.
The Campbells now became convinced that the accident on Flight 811 began with a failure of the S2 switch. Power remained on to the sea latch motors. All it took was a short circuit in the 20-year-old wiring, which had been found to be frayed on other aircraft, to start the motors up. The aluminium locking sectors were too weak to stop the latches turning, and the cargo door burst open.
The National Transportation Safety Board determines that the probable cause of this accident was the...
After waiting a year for the NTSB report, Kevin and Susan Campbell expected it to match their theory of what had led to the accident on Flight 811.
I assumed that we would have a report come out that this was an electrical malfunction, and was staggered when they came out and said that the door had been mishandled.
The report focused entirely on the fact that the door lock must have been mishandled by the ramp attendant. That was disappointing, and we felt that they must have been at a different hearing from the one we were at.
So how had the NTSB come to their conclusion?
There was other evidence that we had found during our investigation of improper procedures by the United mechanics and ramp people. So we were convinced that there was, we could use the word abuse being done on the doors. The doors were sort of abused and weren't maintained very well. We concluded that the probable cause was mechanical.
For the Campbells, the NTSB's failure to mention the electrical problems just wasn't good enough.
What they said happened was the door was closed, the locks didn't fully close, they just partially closed, just hanging on the pins, and then they closed the outer handle. But it just simply can't happen because that part of the locking sector is still intact. Just simply can't happen. You can't close the outer handle unless these are in the fully locked position. It's the only way that the outer handle will close. And just closing this manually, you can't exert enough force to actually damage this part of the locking sector. All it does is just butts up against there. If the locks aren't fully closed, it just simply butts up against them and goes no further.
They went back to investigating the accident on Flight 811 and soon found disturbing evidence of how it could and should have been prevented. After the Pan Am incident in 1987, it turned out that Boeing had issued a directive to the airlines on how to correct the weak aluminium locking sectors.
The airworthiness directive that came out was to replace the aluminum sectors with steel sectors that could not be bent. And there were some some interim requirements for inspections to be performed until what they call terminating action, the steel sectors were installed.
The fix was cheap and simple, but getting it done was not.
The actual cost of the modification, changing these locking sectors to steel, was $2,000 per aircraft. But it took 10 hours to do it, and that's where the money was. Taking the aircraft out of service for 10 hours, that's millions of dollars.
The Campbells found that back in 1987, the Federal Aviation Administration, who were meant to enforce improvements, had given the airlines 18 months to comply with the modification. Within a year, Lee Campbell and 8 others would die in an avoidable accident. So why weren't the airlines forced to fix the problem sooner?
If these airplanes, these large commercial airplanes, are grounded, it's an economic disaster. So what they do is they lobby in the regulatory agency in the United States, it's the FAA, to allow them to do the fixes over time when the airplanes are in for normal maintenance. And that way, they're not taken out of service. But when they do that, when they allow the airlines, the air carriers, and the manufacturers to fix these over time, in essence what the FAA is doing is they're gambling with the lives of the passengers and the crew that are flying the airplanes during the time they're not fixed.
After the deaths on Flight 811, the FAA instantly shortened the deadline for fixing the cargo door from 18 months to just 30 days.
It was only when United had gone from one of the airlines of first resort to one of the airlines of last resort in New Zealand that they just totally out of the blue, we got a letter inviting us over to see them. And when we got there, they were just going to do a PR exercise on us. But we just laid into them, pointed out where they'd all got it wrong.
And you could see them changing during it to realising that we did know what we were talking about and that we'd put a lot of serious effort into it.
One of them actually broke down because they'd never had to meet next of kin before. And it ended up with the Vice President of United taking us round the maintenance facility, and he had people running off in all directions just to get the information that we wanted, questions answered. We could go anywhere that we wanted, and everything was laid on for us because at that stage they realised that we really did know what we were talking about.
The pressure of the Campbells' campaign eventually began to pay off. The vital piece of evidence that could prove them right, the cargo door, still lay 2 miles down in the Pacific Ocean. But as articles appeared in the American press, the NTSB commissioned the US Navy to search for it. 100 miles south of Honolulu, a deep submersible began to trawl the seabed.
We went to Honolulu and waited there while they had their attempts. And they finally recovered the door from 14,000 feet of water, which was the deepest recovery ever at that time. and we were phoned within an hour of it coming out of the water.
But before the Campbells could see it, the door was swiftly removed to Boeing's plant in Seattle. The Campbells went in hot pursuit.
We went over to Boeing and they wouldn't show it to us. So they reckon that the crucial pieces had gone to the NTSB. So again, we got in the car and drove across to Washington, D.C. We arrived at Ron Schleid's office, and Ron looks at his watch and he says, "I can give you 5 minutes." So about 3 hours later, we had the pieces that they recovered in our hand, and they acknowledged that we're definitely correct. It was an electrical malfunction, and that they said they would fix the planes, they would make sure it never happens again, but just don't hold your breath that the report will ever be changed.
Even with the evidence of an electrical malfunction in their hands, the NTSB refused to change their report. Then, in June 1991, fate intervened. A 4-year-old United 747 was sitting on the apron in New York when the C-latch motors started up and the door opened itself.
There was no way that they could hide it any longer. They simply couldn't deny that it was an electrical malfunction that was covering it.
Was that in fact the actual...
Finally, the NTSB publicly issued a revised report that concurred with the Campbells' version.
There was an inadvertent failure of either the switch or the wiring that caused an uncommanded opening of the door.
It's nice that other people know that you're right and had been all along, and that the support that they had given you was vindicated.
The Campbells spent thousands of dollars of their own money on their campaign. They were never interested in a financial settlement for Lee's death, but they did persuade United and Boeing to set up a university scholarship in his name.
I couldn't have lived with myself if we had done no investigating ourselves. It was just something we both felt we needed to do. We didn't even discuss it. We just knew that's what we would do.
Yeah.
But despite long and public campaigns like that of the Campbells, critics fear that the airline industry has not learnt the lessons from Flight 811.
The regulatory agencies, they have a dual charge. One is to encourage aviation, and another is aviation safety. And when they get in a position where you have economics up against air safety, they tend to err on the side of economics rather than safety.
Serious accidents caused by known defects have continued to occur. In the 1990s, known problems with icing on aircraft wings caused a series of crashes. At least 3 planes have had fatal fires due to known dangers from flammable insulation material. And in 1996, a fully laden 747 blew itself up when known faults in the wiring are thought to have ignited flammable vapors in the fuel tanks. Inevitably, experts are skeptical about the aviation industry's record of balancing profit against prevention.
We've seen the wiring problem both in United 811, which was eventually turned out to be the cause of that accident, and also in TWA 800, where we had an explosion in the centerline fuel tank. The industry answer to 20 and 30-year-old wiring, and when the wiring can fray, break, crack, cause a short, which can either ignite fuel, like in TW 800, or open a cargo door, like in United 11. And what the industry says, don't touch it. Don't go in there. Don't inspect it. Don't try to fix it. Don't try to remove it, because it's so brittle that if you go in there to try to fix it, you're going to do more damage than you're going to do good. And that's what I call the ostrich approach to maintenance and safety. You know, we've decided that you can have an spark of ignition in the centerline fuel tank of a large air carrier. But so far we've been lucky. We've only had one every 10 years. We've only blown up 3 or 4 airplanes. You know, to go in and replace this wiring would ground all these airplanes, would be astronomically expensive. You know, 1 airplane every 10 years, 1 airplane every 5 years, 200-300 people, cost of doing business. Cost of doing business. And that's a great economic analysis, and unless your mother or your child is on board one of these airplanes that happens to pay the price for their economic satisfaction.
For some of the survivors of Flight 811, the cost has been heavy.
Each crew member handled it differently. I know there are still 2 crew members that have never set foot on an aircraft again. It was very difficult for me. I was diagnosed with severe post-traumatic stress disorder. You can't reason, you can't think. Making the slightest decision is very difficult. You're just at a total loss. So it was very difficult to cope with.
A 737 is in trouble. The pilot's blinded by rain. In the cabin, government officials and influential businessmen. The crash of IFO-21 shocks the world. Did a final act of war bring the plane down? The White House demands answers. This was no ordinary flight, but a military jet carrying American politicians. When the investigation is over, the Air Force itself is held responsible. Wednesday, April the 3rd, 1996. A raw spring day near the city of Dubrovnik, Croatia. Rain pelts the runway at the city's airport. A small group of diplomats hurry through the storm, trying to keep dry. They're part of a delegation that's just touched down. Among them, the Croatian Prime Minister and the American ambassador to the region, Peter Galbraith.
The flight into Dubrovnik was a scary flight. We couldn't see anything at all. At that point, I'd been ambassador to Croatia for nearly 3 years, and I'd done a lot of shuttle diplomacy, and it certainly was one of the most uncomfortable.
The weather that made Galbraith's landing so bad isn't letting up. In fact, commercial flights into Dubrovnik have been cancelled. But the ambassador and the others aren't waiting for a commercial flight. They're here to greet IFO-21, a US Air Force jet on a delicate mission. The plane is a specially designed 737. The Air Force has a small fleet of these jets to transport high-profile guests around the world. The cabin has everything needed to do business and politics 10,000 meters in the sky. Today, the cabin is filled with what the military call DVs, Distinguished Visitors. This group is led by United States Secretary of Commerce, Ron Brown.
Ron Brown was a very smooth, capable individual. He was a Washington insider. And he had all the skills that go with that.
Brown is a star in the Democratic Party.
I obviously will do everything that is
He played an important role in getting Bill Clinton elected president. Under Clinton, Brown was appointed the first African-American Commerce Secretary in the country's history.
The United States companies that are here today are eager to engage in dialogue with government and business leaders, and more importantly, to do business.
Today, that job has taken Brown to one of the most troubled areas in the world. For 4 years, civil war ripped Bosnia and Croatia apart. But just a few months ago, an uneasy peace began. As Commerce Secretary, Brown is helping to rebuild the local economy.
Ambassador thinks we should.
The philosophy behind it was that the peace would not be durable unless there was economic progress in the region, that was really critical to the peace.
Brown's 3-day tour started that morning in Tuzla, Bosnia, where the group toured an electrical plant and ate hamburgers with American troops stationed there.
Being a former Army man myself, I know what being away from home is like, so we thought we would bring a little bit of home to you.
The final stop on today's tour is the ancient coastal city of Dubrovnik. Before the war, it was a vital part of the country's tourism industry.
It was my idea that Ron Brown should go to Dubrovnik. The Croatians were very eager to get the word out that Dubrovnik was still standing and that it was still a tourist destination. So I thought it would be very useful to have Ron Brown and the delegation go there.
But on this damp day, Dubrovnik is not at its best, or even visible. Fog presses down from the sky, obscuring the city and the beautiful Adriatic coast. To the north of Dubrovnik flies IFO-21. Its pilot is Captain Ashley J. Davis. His colleagues call him AJ.
Departure IFO-21.
IFO-21. From the cockpit, Davis can see some clouds ahead that he wants to avoid.
I'm left here just a couple of miles for a build-up.
IFO-21, this is approved as requested. Climb and maintain flight level 160.
Up to 160 now. IFO-21.
It's 2 o'clock in the afternoon. AJ Davis and his crew have been on the go since dawn. While the cabin of this plane is built for comfort, the cockpit is virtually identical to a standard-issue 737. AJ Davis grew up in Baton Rouge, Louisiana, and dreamed of being a pilot. He made it and has been on the front line of American military efforts. In the past, he flew mid-air refuelers high above the Persian Gulf. But now he pilots diplomats and other officials from around the world. It means a lot of traveling and a lot of time away from his wife and 2 children at Ramstein, an American base in Germany. According to the Air Force ranks, Shelley Kelly is a technical sergeant. Today on IFO-21, her main job is to make sure the passengers have everything they need.
Mr. Secretary, something to eat.
No, thank you. I was wondering how our time's looking.
The diplomats are expecting to arrive in Dubrovnik by mid-afternoon, but they've been running late all day.
I can check to find out for sure if you'd like.
Yeah, thank you. Early would be good.
As the plane nears Dubrovnik, AJ Davis calls the United States Air Force Weather Service for an update.
Metro, IFO-21, how copy? Over.
IFO-21, copy loud and clear. Weather for Lima Delta uniform as follows. Rain. Sky conditions 500, broken. That would be ceiling. How well do you copy?
Metro, IFO-21, copies. Yeah, we've been in it all day. Are you expecting any changes in the weather?
Pretty much continued rain, over.
Copy. Rain. Thanks for your help. So, let's see the sights of Dubrovnik.
Only 4 months after a peace treaty was signed, the skies over this part of the world aren't guaranteed to be friendly. Planes are still required to fly in certain highly restricted lanes. While he's aware that there are flight restrictions, Davis has never flown in this part of the world before. As he nears the Croatian border, he gets an unexpected warning.
IFO 21, this is Magic 51.
Magic is the call sign for the peacekeeping airborne early warning aircraft that watches air corridors like a traffic cop.
Be advised, you're leaving an approved corridor. Please reroute immediately.
Davis isn't off course. He's flying the exact route he had planned. But without knowing it, Davis and his plane are flying out of approved airspace. They're flying into potentially dangerous territory.
You're leaving an approved corridor. Reroute.
Roger, Magic. Our error. Rerouting now to proper corridor. Over. The second time today.
The approved corridors do change, and Davis and his crew should have been informed. To stay on an approved course, Davis will have to swing out to the west. It's an embarrassing situation that's going to cost them time.
Shelley, AJ, we've been directed to reroute. We'll be arriving about 15 minutes late at Dubrovnik. Apologies to all back there.
Ladies and gentlemen, could I have your attention, please? Unfortunately, there will be a slight delay on our arrival into Dubrovnik.
DVs aren't going to be happy at all. The weather ahead will probably slow us down even more.
Outside his plane, the heavy rain continues to crash down. Flying toward an unfamiliar airport with a cabin full of businessmen and diplomats, Davis has a difficult task ahead. What happens to this plane and its passengers over the next several hours will capture the attention of the world. A heavy rain soaks a small airport in Dubrovnik, Croatia. Headed towards it is a US Air Force 737 carrying 35 people on a trade mission. Leading the delegation, US Secretary of Commerce Ron Brown.
We'll see which path the ambassador thinks we should follow.
Dubrovnik approach, IFO 21, level 100.
Dubrovnik approach, good afternoon. Maintain 10,000 feet for beacon approach. Runway 12.
Okay, descending to 10,000 feet, IFO 21.
The weather is so bad today that commercial flights have been cancelled. As they approach the airport, the rain isn't letting up. But the crew is dealing with more than just bad weather. The recent civil war has taken a heavy toll on Dubrovnik's airport. It had been closed for several years and is waiting for a new landing system.
The airport was totally trashed by the Serbs who had taken over the airport during the '91 war. And they really went out of their way for the destruction. They destroyed the instrument landing system. The new one was on order.
Around the world, airports use sophisticated technology to help planes take off and land. Doppler radar warns of incoming storms. Glide slopes help pilots stay on course to land. The devastated Dubrovnik airport has none of that. It doesn't even have radar to see the planes that are coming in for landing. Instead, the airport is using so-called non-directional beacons to guide planes towards the runway. In the aviation world, it's ancient technology.
There are many non-directional beacons used in the United States and throughout the world, but they're an older navigational aid, and in fact, they were on the way out.
The system in Dubrovnik has 2 beacons on the ground, which send out signals to the plane. When the crew receives the signals, they consult their charts and follow the course that will take them to the airport. The crew of IFO 21 is still waiting to hear the first signal when they get a call from the ground.
9A CRO to IFO 21.
IFO 21, I read you, 9A CRO, over.
Another plane, this one carrying Ambassador Galbraith, had touched down earlier in Dubrovnik. The pilot of that plane is an experienced flyer who's very familiar with the area. He wants to let the crew know what to expect.
IFO 21, we landed about an hour ago. The weather was at minimum.
Adjusting the wording to split if you have to execute the missed approach. Over.
Roger, 9A CRO, we read you. Out.
Diverting wouldn't be welcome news for the members of the trade delegation.
The pressures to get the passengers to scheduled news conferences and other activities were probably pretty high.
As Davis closes in on the airport, the Dubrovnik tower calls again.
IFO 21, report level.
IFO 21, 5,000.
IFO 21, roger. Descend to 4,000. Report Kilo Lima Papa.
Down to 4,000, IFO 21.
Sir. Thank you.
Flying above the storm, the crew finally hears the radio signal from the first beacon.
Age. At Kilo Lima Papa, we're tracking outbound at 119 degrees.
119 confirmed.
Mr. Secretary, we're landing.
We'll take this up later, Adam.
It's not very broken up down there. I can't see through it. Tim?
The clouds are thick. The crew can't see the ground. They have to trust their instruments as they descend through the storm.
IFO 21. Sir, we are inside the locator, inbound.
IFO 21, roger. Cleared for beacon approach. Runway is wet.
IFO 21.
A.J. Davis flies blind through heavy rain and cloud cover. He expects to see the airport any second.
Pull up! Pull up!
IFO 21, do you read?
Just before 3 o'clock in the afternoon, Dubrovnik Tower loses all contact with IFO 21.
IFO 21, Dubrovnik approach, do you read? IFO 21, do you read?
Without approach radar to track the plane, controllers have no idea where it is. Perhaps the plane has diverted to another airport.
IFO 21, do you read?
But as the minutes stretch on with no word from the American plane, local controllers are taking no chances.
Initiate emergency procures.
Near the end of our shift, we heard about the possibility of a missing plane. We didn't know who was on the plane. We had no details about the flight. For situations like this, there is a certain procedure, and we just waited for more information.
Peter Galbraith is waiting at the airport with Croatia's Prime Minister.
It was clear from my own flight in that this was a very marginal landing. I did not expect them to attempt the landing in Dubrovnik. The Croatian Prime Minister came up to me and pulled me aside and he said, "We've lost radio contact with Ron Brown's plane." I got the State Department Operations Center on the phone and he's asked to activate the U.S. military to start search and rescue activities.
Word goes out to the chain of air traffic control centers.
Američke borbene snage. Jeste li imali nekakav kontakt sa tim zrakoplovom?
But no one has had any contact with IFO-21. The search and rescue effort focuses on the approach to the airport. Perhaps the plane had ditched into the Adriatic.
At the time, I was about 100 miles away. I was in Brindisi, Italy. We launched 2 of our MH-53 helicopters with Special Tactics Air Force personnel on board, headed to Dubrovnik.
For hours, there is no sign of the missing aircraft. The weather conditions are getting worse.
Fog was in, thunderstorms in the area, low visibility.
IFO-21 Dubrovnik approach, do you read?
IFO-21 has a CPI, or crash position indicator, on board.
IFO-21, do you read?
If the plane went down, the CPI should be sending out an ultra-high frequency signal.
IFO-21.
But the Dubrovnik airport, as well as lacking radar, does not have the equipment to pick up the signal.
IFO-21 Dubrovnik approach, do you read? IFO-21, do you read? IFO-21, do you read?
As the hours pass, poor visibility frustrates the searchers.
They arrived off the coast, and they were over water looking for the crash.
Hours after the plane disappears, police respond to a tip. A local villager has seen something on the hill above his house. It's a long way from the coast where the search is concentrated.
We went up with 2 vehicles to check the mountains. The weather was extremely horrible. Strong rain and thick fog. So we went on foot for about an hour up that mountain. Then we came close.
It's almost 7:30 at night, 4.5 hours after the crew called for clearance to land. The crash of IFO-21 is finally confirmed. The news races from Dubrovnik to America.
The crash site has been reached by Croatian police, and I've just received word that there's also a Croatian doctor on the scene.
The tail section is the only substantial piece of IFO-21 that's left. Debris and bodies are scattered across the mountain.
These were hard moments as we were walking over the boulders, not knowing if we're going to step on someone's body. These are the moments that you can't forget.
Then, almost miraculously, police make a heartening discovery. Inside the tail section, they find a survivor. It's Technical Sergeant Shelley Kelly.
As we arrived at the tail section, one policeman went inside and found the body of a stewardess, and he tried to help. That was our hope. We wanted to help. We wanted to save every life, and hers was our chance. We were counting on it.
In the darkness, they realize that Kelly needs immediate medical attention if she's going to survive.
When I realized that there was no one to help, I radioed the police central station in Dubrovnik and got them the location of the crash site. By then, it was completely dark.
St. John's Hill is alive with close to 100 Croatian policemen and military. American forces are also rushing to the scene. Enormous rocks and treacherous conditions make the wreck site difficult to reach. But there are also remnants of the recent war. Mike Canavan is in charge of the US crash recovery operation.
I met a Croatian major. He told me that he was going to be the guide that would take us up to the top of the mountain. And at that time, he happened to mention that there were several minefields between where we were and the crash site.
It takes almost 2 hours for Canavan to finally make it up the rocky hill.
We had been walking for some time, and it was very dark. And all of a sudden, I saw something that was darker, and I didn't know what it was. And I reached out, and it was an aircraft engine.
On top of the hill, the weather is making it impossible for helicopters to land. Emergency workers can't wait for the weather to clear. They have to get Technical Sergeant Kelly off the mountain immediately. She has a broken spine and other severe injuries. But if she can be kept alive, rescuers hope she can shed some light on what went wrong. With Kelly off the mountain, the search for other survivors continues. Finally, in the darkness, rescue workers find the body of Ron Brown, the US Commerce Secretary. In fact, as rescuers continue to comb the hillside, all they find are bodies. A.J. Davis and the rest of the crew were probably killed instantly. All the other members of the trade delegation are also killed. As dozens of emergency workers continue their grim search, a call comes from Dubrovnik. Technical Sergeant Shelley Kelly is pronounced dead in the ambulance en route to hospital. No one has survived the crash of IFO 21. A grim spring rain hammers down on the mountains of Croatia. Near the Dubrovnik airport, a 737 has crashed. The jet was an American Air Force's plane on a trade mission through the region. Police and members of the military have searched for survivors, but all 35 people who were on the flight are now dead. Including the American Secretary of Commerce, Ron Brown. In the darkness, the rescuers begin a very different job. Mike Canavan is with the US Special Forces.
Once we realized there were no survivors, the mission changes. It goes from, there's no one to rescue. Now, you have to recover remains.
By dawn, the weather has improved. Peter Galbraith gets his first glimpse of the crash site.
We walked up the mountain. The weather was somewhat better. And near the top, there was the fuselage of the plane, rear part of it, and debris all over the place. And then on the other side of the ridge were the bodies. There's nothing in the world that compares to a plane crash.
One thing that my folks did on the mountain and then down in Dubrovnik is they did this with dignity and respect. And I thought it was done exceptionally well.
Ladies and gentlemen, the Vice President and the First Lady and the members of the Cabinet and I wanted to come here to be with the employees of the Commerce Department at this very difficult hour. Hillary and I have just come from Ron Brown's home, visiting with Alma and Michael and their family and friends who are there.
As the truth sets in, the hard questions begin. How had a specially redesigned US Air Force 737 crashed on a hillside in Croatia? Was it simply bad weather? Or in a war-ravaged part of the world, was there another cause?
Purpose of the accident investigation team, I can guarantee you that they will be extremely thorough in their analysis in trying to determine the causes of this accident.
Because of the high-profile nature of the passengers, rumors begin swirling immediately. Howard Swansea is one of dozens of experts assigned to the team.
In every accident, there's always a lot of speculation. In this particular case, you had a high-ranking U.S. government official. And so by the time we had even got to the crash site, there was just quite a bit of media attention around it. And there were fragments, pieces of aircraft miles away from the wreckage. So my idea was to get as much information or collect as much artifacts or physical evidence as I could.
Right from the start, the investigation team is at a disadvantage. They discover that there's no cockpit voice recorder or flight data recorder on the plane. What's standard for passenger jets is not required in the Air Force.
I had assumed that the Air Force and these VIP flights had higher safety standards than commercial flights. And so I was really shocked to learn that the standards were generally lower than those for commercial aviation.
Without the standard tools, investigators can't afford to overlook anything. The wreck is almost 3 kilometers from the airport. How did a trained crew get so far off course? As Swansea examines the wreckage, Nelson Spornheimer is brought in to look at other evidence. An expert in aerial navigation, he plots the plane's doomed final minutes. To trace the last moments of the flight, he turns to the sky and the US Air Force radar plane, which had been patrolling the region.
IFO 21, this is Magic 51. Be advised, you're leaving an approved corridor. Please reroute immediately.
Rerouting now to proper corridor. Over.
Apart from heading out of approved airspace, Spornheimer finds nothing unusual about the plane's flight until the end.
The radar track that I was given was from an AWACS aircraft and showed that the en route portions of the flight from about 100 miles prior to the airport were entirely nominal.
The last segment of the flight, however, beginning 20 kilometers from the airport, is different. On their final approach, the plane begins to head off course. They start flying in a straight line, which heads right into the mountains.
My initial look at the flight track of the aircraft showed a 7-degree bearing error in the final segment of the approach.
A small error when traveling at hundreds of kilometers an hour could quickly lead to an enormous problem. But why would the plane get off course at the end of the trip if the rest of the flight showed no major navigational problems? Even in bad weather, how had the crew become so lost? Spornheimer examines the outdated navigational equipment at the airport. badly damaged during the recent war. Perhaps it had malfunctioned. 2 separate navigational beacons are used for landing in Dubrovnik. One guides planes to the runway, the other lets them know if they've gone too far. The first is located on nearby Kolosep Island. It transmits a specific Morse code signal to make it easily identifiable. When they hear it, all Davis and his crew need to do is fly a heading specified on their landing charts. If they do, they should eventually arrive at the airport. The second beacon is located at the airport itself. It's a fail-safe device. If the crew hears the beacon before they see the airport, they have to declare a missed approach and circle around to try landing again. In fact, the plane that brought Peter Galbraith to Dubrovnik just minutes before IFO 21 only landed on its second attempt.
IFO 21, I read you, 9ACRO, over.
Suggesting diverting to
Split if you have to execute the missed approach.
over.
Roger, 9ACRO, we read you. Out.
But after studying the equipment, Spornheimer doesn't believe it played a role in the crash.
Both the non-directional beacons were found to be operating normally by flight tests within a few days after the accident.
There are bizarre rumors of an even more sinister theory. Perhaps Davis was following a decoy beacon put in the mountains on purpose. In a troubled region, was this an attack on the trade mission?
To get a signal that is strong enough to be heard, you have to have a very large ground system, which is difficult to establish in rocky, sandy soil. So it would be very expensive and very time-consuming to set up an NDB in the mountains.
Such an elaborate scheme would be nearly impossible to pull off. No evidence is ever found of a decoy beacon. The investigation continues. In the wreckage of the Air Force flight, investigators discover an important piece of the puzzle. The plane's ADF, or Automatic Direction Finder, is recovered. It appears to be working, but only one of the units had been installed on this jet. To perform a proper landing in Dubrovnik, a plane requires 2 ADFs. The device listens to the signals put out by the land-based beacons, but it can only listen to one at a time.
We're still not past it. I'm tuning back to KLP.
Flying with 1 ADF, the crew can listen to either the beacon which is telling them how to get to the airport, or the beacon which is telling them they've gone too far. They can't do both at the same time.
That would have required 2 ADF receivers in the aircraft, which the accident aircraft had only 1. And only having 1 ADF restricted their ability to follow the approach accurately.
I got CV. We're still not past it. I'm tuning back to KLP.
By quickly tuning back and forth between the 2 beacons, the crew can use 1 ADF to listen to 2 signals. But it would have added stress to an already difficult landing. And it's another surprise. The Air Force jet wasn't adequately equipped to land at this airport.
You're talking in a very short time span of making the approach. It's going to become rather difficult in trying to dial both to keep listening to the code if you're also trying to search for your course and headings.
As he continues to study the path that IFO 21 took, Nelson Spornheimer focuses on an S-shaped curve in the plane's flight. It's the sort of path a plane would take when looking for a signal from a non-directional beacon. But just when the crew should be looking for the beacon signal, the S-turns disappear.
At about 2 or 3 miles inside the final approach fix, for the next 7 or 8, 9 miles, the flight track is perfectly straight.
Instead of trusting the navigational system that was in place, even though it was primitive, the crew suddenly seems to give up. And Spornheimer thinks he knows why. Fighting heavy rain and hampered by a single direction finder, Spornheimer believes the crew resorted to another, even older piece of technology to find the runway, something called INS, or Inertial Navigation System.
An INS system uses gyroscopes to maintain an awareness of how much the airplane turns and banks.
After entering a specific geographical position at the beginning of a flight, an inertial navigation system tracks all the turns a plane makes. It's a self-contained system on the aircraft. But there is a potentially enormous problem. If the gyroscopes don't perfectly calculate every single maneuver of the plane, a pilot can be off course.
It's not very broken up down there. I can't see through it. Tim?
The crew might have thought that switching to this system would help them find their way. But in this case, it might have put the plane dangerously off course.
INS drift in this case was probably, in my view, the primary reason the aircraft ended up where it was.
Investigator Howard Swansea examines the Jeppson approach chart the crew was using as they attempted to land. Hampered by poor visibility and relying on the inertial navigation system, their charts would have been a key aid. But when he takes a closer look at it, he notices something peculiar. A key figure, the minimum descent altitude, isn't accurate. The minimum descent altitude is the height where pilots must be able to see the airport. If you can't see it at that height, you have to abort the landing.
Each country has the responsibility of developing these procedures and then publishing information so that other nationalities as well as their own air crews can fly those approach procedures.
Swansea discovers that the minimum descent altitude on the chart doesn't meet American aviation standards. Given the mountainous terrain, it should have been more than 2,800 feet. But the chart the crew was using said it was just over 2,100 feet. It means that the crew could have flown almost 700 feet lower than experts in the US thought was safe without having to abort the landing. Combined with the other problems the crew was dealing with, the non-standard chart sealed their fate. Struggling to find the airport, they were straining to see through the clouds, assuming they were still safely above the mountains. But why wasn't an Air Force jet properly equipped to land in Dubrovnik? And why didn't the crew have the right landing charts that would have made even a difficult flight safer? The answers are found at an American military base in Germany, with some of the most senior members of the Air Force. In the spring of 1996, a US Air Force jet crashed just outside the airport in Dubrovnik, Croatia. None of the 35 people on board IFO-21 survived. The plane was a specially redesigned 737, but the investigators have found that the crew didn't have the equipment it needed to safely land in the war-ravaged airport, and that the charts they were using weren't up to American aviation standards. To discover why the crew were attempting to land in such difficult circumstances, the investigators questioned Colonel John Mazurowski. He's the operations group commander for the airlift wing in charge of the flight. His job is to provide transportation for a growing number of distinguished visitors. But these are tight budget times. Mazeroski has been told to do more with less.
What I'd like to talk about now is the Jeppesen approach subject.
One of the major focuses of the investigators is the Jeppesen landing charts the crew were using. The charts, drawn up for most major airports, give crews a vast amount of information, including what to do in the case of a missed approach. But investigator Howard Swansea has already found that these charts were not up to US standards.
The Air Force had a directive that required all procedures in foreign countries to have gone through a US or their evaluation process prior to an Air Force crew being able to fly that approach.
Landing at the Dubrovnik airport had not been approved. The Jeppesen landing charts that did exist for the airport had not been reviewed. It's the reason that Howard Swansea found a difference between what the charts said and what was considered safe by the Defense Department. Mazeroski believed that restricting his planes to approved airports would severely limit some of his missions. It takes time to check all the airports out. He had asked for the review to be waived for some airports, including Dubrovnik.
This Jeppesen approach waiver, what caused you to initiate this?
It just seemed like we had been using these approaches for years. Safety didn't seem to be in question.
But the Defense Department waiver was never granted. The approach for Dubrovnik was never approved. Yet even without the safety clearance, the Air Force continued to land there.
IFO 21, level 100.
Dubrovnik approach, good afternoon.
The airport in Dubrovnik was far below modern standards. The charts used to land there hadn't been checked by the Department of Defense. Nevertheless, senior Air Force officials had decided to permit landing at Dubrovnik and other airports they were flying into.
In fact, none of them have been approved in this time frame.
Not to my knowledge, sir. No.
In the end, a fatal combination of factors had come together to cause the crash of IFO 21.
Dubrovnik approach, IFO 21, level 100.
Dubrovnik approach, good afternoon. Maintain 10,000 feet for beacon approach. Runway 12.
IFO 21.
The crew were fighting bad weather. They were landing in an unfamiliar airport, which was hobbled by old technology. The unapproved charts made a bad situation much worse. After an investigation involving nearly 150 interviews, the final report on the crash of IFO 21 exceeds 7,000 pages.
How much of the weeping we have done this last week because there were so many brilliant young people on that plane with him from different backgrounds and different racial groups. Why? Because Ron Brown could see in them the promise of a new tomorrow.
The results of the investigation fault several individuals and institutions. Dubrovnik Airport is singled out for an improperly designed instrument approach procedure. Today, automatic direction finders are no longer needed to land at Dubrovnik. The airport has replaced its approach equipment with the instrument landing system which was being delivered at the time of the accident.
I got CV.
The final report says A.J. Davis and his cockpit crew are responsible for flight errors. And, like a bullet piercing the heart of Air Force operations, leading military figures are blamed for a failure of command. In the aftermath of the report, 2 senior members of the Air Force are relieved of their posts. The Air Force severely reprimands Colonel John Mazeroski for dereliction of duty. He is demoted and eventually retires as a major. 13 other officers are also singled out for their roles in connection with the crash. The Air Force also changed the way it did business. All military aircraft were ordered to carry flight data recorders and cockpit voice recorders. No aircraft is allowed to fly into an airport without approval from the Department of Defense, not even for high-ranking diplomats.
IFO-21. Sir, we are inside the locator, inbound.
IFO-21, roger. Cleared for beacon approach. Runway is 1.
IFO-21.
The Air Force Command was held accountable for the accident. But it's the pilots, the crew, and the passengers of IFO-21 who paid the ultimate price for oversights made by the 86th Airlift Command. A luxury jet on its maiden voyage is jolted in midair.
Declare an emergency. We have a wingtip!
The plane has lost part of its wing.
It became clear that we were in very, very big trouble.
The crew struggles to land the badly damaged plane.
November 600, X-ray Lima, declare an emergency.
But the trouble isn't over when they hit the ground. The crew is detained and questioned by police. Somehow, this small plane has triggered the worst crisis in Brazilian aviation history. September the 29th, 2006, in São José dos Campos, Brazil.
3, 2, 1!
It's a big day at Embraer headquarters. The Brazilian aviation firm has just sold a brand new private jet to XLR, a US charter company. The price tag, $25 million.
It's a beautiful airplane, and there was a beautiful little ceremony that Embraer had in the hangar just before we got on the plane. And the guys from XLR were particularly proud.
The Legacy is a modified regional jet. The cabin redesigned for comfort. It can seat up to 13 people. And in its first 4 years of service, Embraer has delivered almost 100 of these sleek business jets. XLR will use the jet to fly customers around the world. But first, the company has to get the plane up to the United States. Joseph Lepore and Jan Palladino will be at the controls for the jet's maiden voyage. They've been down in Brazil for a couple of weeks, getting familiar with the new plane. Joe Sharkey is a reporter for the New York Times. He's been offered a free ride home.
We were delivering an airplane, basically, and my role was hitchhiker, and they kindly invited me along.
The Legacy jet is heading to Manaus in northern Brazil, a stopover on its way to New York. Half an hour after takeoff, the Legacy is flying over the heart of Brazil. The countryside stretches out below. The view out of the window is spectacular.
I glanced out, and I was
amazed. Just to the horizon, nothing but treetops. And I just remember how pretty it seemed.
At 10 minutes to 4 in the afternoon, the Legacy jet makes contact with controllers at the Brasilia Area Control Center, still nearly 100 kilometers away.
Brasilia, November 600 X-ray Lima, flight level 270, good afternoon.
CAW 229, raise altitude 3952, raise altitude 329. Raise altitude. Yes, Roger.
75% of the country's air traffic is handled by the controllers in this room.
The traffic volume is larger than in any other control center in the country.
One of the many planes they'll be dealing with today is the Legacy jet. Every flight that's handled by Brasilia ACC appears on computer screens as a small circle, moving in the direction of the plane. The computer also displays the plane's actual and planned altitudes.
November 600 X-ray Lima. Squawk ident.
Roger.
Palladino sends out a
November
signal.
600
Controllers use it to confirm that the data on their screen is coming from the plane
Radar
they think it is.
surveillance. Radar surveillance.
An hour later, the flight has settled into a familiar routine.
Mood sort of settled down, everybody was working, and it was just a very, very calm and peaceful time. I was transcribing notes from one of the interviews from the Embraer tour.
Brasilia, November 600 X-ray Lima.
But in the cockpit, Palladino is having trouble getting back in touch with air traffic controllers in Brasilia.
Brasilia, November 600 X-ray Lima.
He can't raise controllers on the frequency he used almost an hour ago. He tries other channels.
Brasilia, November 600 X-ray Lima. Brasilia, November 600 X-ray Lima.
November 600 X-ray Lima.
After 12 attempts, Palladino finally gets in touch with Brasilia ACC, this time with a different controller who provides radio frequencies for future contact.
Contact 123.32. 26.5.
I'm sorry, I didn't get the last two. Sorry, say frequency one more time for November 600 X-ray Lima.
The Legacy loses radio contact again.
Brasilia, November 600 X-ray Lima.
As the pilots try to restore communication with Brasilia, the plane continues to power through the sky. It's just minutes before 5 o'clock.
Suddenly there was the loudest bang I've ever heard in my life. The concussion itself seemed to affect every atom in my body.
What the hell was that?
Just fly the airplane, dude.
They're an emergency. Sit down back there.
No one's sure what's happened to the jet. But when Joe Sharkey looks out of the window, he's stunned by what he sees.
The end of the wing was chopped off and it was serrated. It looked like it had been chewed off. It became clear that we were in very, very big trouble.
XLR Vice President Ralph McHaley rushes to the window for a look at the damage.
I said to Ralph, "How bad is it?" And he looked at me and he said, "It's bad."
With more experience flying this type of plane, co-pilot Palladino takes over control of the limping jet.
Just let me fly the thing, dude. All right? We're descending. I want to get down.
Okay, it's yours.
The crew still can't make contact with controllers.
November 600 X-ray Lima, declare an emergency. Do we have a wingtip? No. Damn it.
The entire tip of the Legacy's wing is breaking up. That affects airflow and is making the plane hard to control.
Yeah, you okay?
As the plane begins to descend, passengers in the back are worried that the damaged wing is getting worse.
Our main concern was that wing, but it had taken such a hit that the structural integrity of the wing was obviously in question. The leading edge was separating.
With so much damage to the wing, the pilots can't turn sharply. Too much stress could rip the wing right off.
We were in a position where we realized we were going to die.
I thought of my wife, and I thought, well, okay, one thing I can do is I can write a note to my wife, which I did. I took out my reporter's notebook, and I wrote, a short note saying that I loved her and that, just saying what I could.
The Amazon is a bad place to have to land a plane. It's a dense jungle for as far as the eye can see.
There's nothing down there but trees. And I thought, where are they going to put this airplane down?
Damn it. Just hours into its maiden voyage, the badly damaged jet is going down. Palladino and Lepore's flying will soon be analyzed and debated throughout Brazil.
Chart.
The verdict against them will be harsh.
Please answer, November 600, X-ray Lima.
The crew of the Legacy jet searches desperately for a place to land their crippled plane. Captain Joseph Lepore finds a small military base on his chart.
November 600, X-ray Lima, we have an emergency. State your emergency. November 600, X-ray Lima, declared an emergency. We need to land at Sierra Bravo Charlie Charlie. Is that your airport? Affirmative. Do you know how long your runway is? 2600 meters. Stand by. 2600, that's good, right? 8,000 feet? Okay, we're coming in. We're declaring an emergency. This is November 600, X-ray Lima. Did you see something? Something hit us.
2,600 meters is more than long enough to land a Legacy, but the crew doesn't know how the plane will respond when it touches down.
The canopy of green, there was a slash of brown, 2 miles away. I heard Joe say, "There's an airport."
Sierra Bravo, we see you. We're coming in.
Finding an airport was a stroke of luck, but the crew's troubles are far from over. Now they have to get the damaged jet safely on the ground. Palladino and Lepore can't configure their plane for a routine landing.
Hold it. Let's dump the flaps at the top of the flare, right? So give me 9 on the flare. 9.
Extending flaps increases the size of the wing. Since a bigger wing can generate more lift, pilots can slow down to land.
You good? Yeah, I'm good.
With all the damage they've sustained, the crew doesn't want to put too much pressure on their wing. They won't be able to extend their flaps until the last moment. They'll have to land faster than usual.
Yes, everyone sit down back there.
When you land under those sort of circumstances, you're landing faster than you normally would. And you get a real appreciation of just how fast an airplane is actually moving, because you're coming down like gangbusters. I see these trees now, at ground level. Just sort of, it looked almost like a movie with one of those moving backgrounds. And I'm thinking, I hope this runway doesn't run out.
Got it.
Palladino hits the brakes hard.
Good. Good. You got it. Hold it.
Then finally the plane begins to slow.
Good job. Oh, man.
And then finally, we just did come to a halt. There's that beautiful silence that occurs when the engines are shut down and everything was just quiet again.
For more than 25 minutes, the business jet had flown with part of its wing torn off. There's also damage to the plane's tail. Somehow, high over the rainforest, something tore into the plane. The bizarre day takes another strange twist. Because they've landed at a military base, soldiers confiscate the passports of everyone on board.
And that's the point at which I realized that we were in custody. I don't think the others on the airplane had the immediate sense that this was a custodial situation.
Along with the 2 pilots, the jet's passengers are taken to the nearby airbase. The emergency on board the Legacy jet has thrown Brasilia ACC into turmoil. But it's not the only problem controllers there are facing. Another plane they're expecting to see hasn't shown up. Goal Flight 1907 should be on radar in Brasilia. The missing flight is a Boeing 737 with 154 people on board. It's been in the air for 2 hours and should be nearing Brasilia. But controllers there can't find any trace of that plane.
Manaus, there isn't any gold. There isn't any gold with us here.
It's on its way.
They check its status with controllers in Manaus, who were last in contact with the plane.
Eu pedi para encerrar a
Anxiety was
instrução,
high, and controllers were
além de
confused
ser
about what to
instrutor, eu
say.
sou supervisor
They didn't
também,
know
mas
what
no
was
dia eu
happening.
estava como instrutor.
Deep in the Amazon, those who were on the XLR jet are also struggling to figure out what happened.
We hit something, man. That's all I know. Maybe it was a condor.
Are you kidding? It was 37,000 feet.
Well, maybe it was a military jet.
No, I think the plane must have exploded and we flew through the debris field. There would have been more impact.
As they're trying to piece together the day's strange events, the group gets some shocking news. A Gol flight has crashed. It's the plane that's been missing.
I just heard the 737 went down in the Amazon right where we were.
It was like a thunderclap. The world changed immediately. And Joe and Jan were just stricken. I don't think I've ever seen two more anguished men in my life.
The Gol flight crashed right where the Legacy lost a piece of its wing. It can't be a coincidence. Approximately 100 kilometers from the military base, the wreckage of Gol Flight 1907 has been found.
The greatest difficulty involved the fact that the plane fell straight down. When it hit the ground, the trees covered it up, making it hard to get to.
The shattered remains of the plane litter the jungle floor. The news hits controllers in Brasilia extremely hard.
They had just realized that the worst thing that could happen in air control happened. People were crying. A lot of people had to be dragged out of the room. Things were not under control in the room.
Over the next several days, troops pour over the scene of the Gol crash. The dense jungle slows their progress.
Nós levamos ali aproximadamente para caminhar quilômetro dentro da selva amazônica, nós levamos ali pelo menos 1 hora.
A makeshift helicopter landing pad is carved out of the jungle. It's becoming increasingly clear that no one has survived. 154 people are killed. At the time, it's the worst crash in the history of Brazilian aviation. What had happened in the skies above the Amazon? Investigators face a mammoth job. Colonel Rufino Ferreira is in charge of the investigation into the Gol crash.
An investigator always has to keep an open mind. You can't start with any preconceived ideas. When we arrived at the location of the accident, the only thing we knew for sure was that we had found the plane that was missing.
The wreckage of the Gol jet is spread over more than 2 kilometers. The widespread debris tells investigators that the plane ripped apart before crashing to the ground.
The aircraft disintegrated during fall. It hit the ground in pieces. There was practically no damage caused by the impact with the ground. The plane had already fallen apart.
On October the 2nd, just 3 days after the crash, the plane's flight data recorder is found. Most of the cockpit voice recorder is also recovered, except for one critical part.
In this accident, the impact was so strong that the module separated from the recorder.
Modern voice recorders don't use tape. Conversations are recorded digitally onto a memory module. But that part of the gold CVR has broken free. Without it, the rest of the cockpit voice recorder is useless. While the search for the module continues, Ferreira looks at the information from the 737's flight data recorder. He learns that the plane was flying at 37,000 feet. It was on course and flying level at its assigned altitude. Then, without warning, the plane pitched over and plummeted toward the ground. Whatever happened, it was sudden and catastrophic. The data recorder tells Ferreira that the plane spun 11 times before it hit the ground.
Manaus, I can't see gold. There isn't any gold with us here.
It's on its way.
So it's already in my area?
For over half an hour.
Police investigators want to know what air traffic controllers can tell them about Gold Flight 1907's final minutes.
There was no Mayday. In fact, we never had contact with the Gold jet.
Controllers say there was no warning that the jet was in trouble. It simply vanished. Colonel Ferreira studies air traffic control data from the day of the accident. There is no sign of the Gold flight. But the readings from the smaller Legacy jet capture his attention. It seems to be flying erratically. Instead of keeping to a single altitude, the radar shows it flying up and down dangerously. Perhaps the private jet pilots were testing out their new plane by climbing and descending quickly. They may have collided with the Gold jet as a result of their reckless flying. When that information leaks out to the country's newspapers, it makes front-page news.
The population thought it was unjust that a smaller aircraft was able to make an emergency landing while the larger aircraft with 154 people just fell into the Amazon and everyone died.
Neither Lepore nor Palladino are officially charged, but they are confined to a hotel room in Brazil while the investigation continues. Ferreira interviews the two pilots about what they did and what they saw.
Look, we were proceeding northwest on course to Manaus at 37,000 feet. Okay, we were attempting to contact Brazilian control.
Were you changing altitude?
No.
I was on the plane. Had the plane been flying erratically or doing loop-de-loops or whatever it was, I think I would have had a pretty good story for the New York Times.
Did you say you were flying at 37,000 feet?
Yes, that's right. Flight level 370. We never moved from that.
When he reviews the information from the Legacy's flight data recorder, Ferreira confirms the pilot's story. Although the ground radar shows the Legacy flying wildly, the data from the plane shows that it didn't change altitude at all. But there is something shocking about the Legacy's path. The business jet was flying north to Manaus, the Gold flight south from Manaus. Ferreira can see that both planes were flying at the same altitude, 37,000 feet. He makes a horrifying discovery. For some reason, the two planes were on a collision course. Air traffic is typically routed along specific corridors through the sky, essentially highways in the air. But planes traveling in opposite directions are supposed to be separated by at least 1,000 feet.
The airway system, for instance, between Brasilia and Manaus is very simple. It makes airplanes fly northbound, maintaining even levels and airplanes flying southbound maintaining odd levels.
But somehow, the Legacy jet and the Gol 737 were traveling down the same aerial highway in opposite directions. For long minutes, they were heading straight for each other. It seems more and more likely that the two planes collided. At the crash site, workers find support for this incredible theory. The left wing of the Gol flight is recovered. Investigators discover that about halfway along the wing, it's sliced clean through. None of the other wreckage is sliced this way. The precise nature of the cut tells Ferreira that this is not damage that was caused by impact with the ground.
The damage on the left wing clearly shows that it was caused by a collision with another plane.
The badly damaged wing would have sent the 737 into a spiral dive. The pilots would have had no way of controlling it. The sudden spiral motion would have pulled the plane apart. It's the reason the wreckage is spread over such a wide area. Ferreira finds the most conclusive evidence of a collision on the Legacy's damaged wing.
On the Legacy, we found very small traces of paint that came from the Gol wing.
Considerada como da cor da aeronave, da Gol.
Together, the planes had a combined speed of 1,600 kilometers an hour. At that speed, the wingtip of the small jet easily sliced through the 737. Colonel Ferreira now understands what caused the Gol jet to crash, but he doesn't know why. How had the two jets ended up in the exact same airspace without anybody noticing? Investigators in Brazil now realize that they are dealing with something very unusual.
A mid-air collision is a very rare event in aviation, and it should not have happened with two very modern new aircrafts.
The situation becomes more complicated when investigators study a critical document, the Legacy's flight plan.
Flight plans are filed by using a standard form which is the same all over the world. The form will contain the flight number as well as requested flight level or altitude.
According to this document, when it collided with the Gol flight, the executive jet wasn't expected to be at 37,000 feet. The Legacy's flight plan called for the jet to fly at 37,000 feet only until it reached Brasilia, then descend to 36,000. But the collision took place 850 kilometers northwest of Brasilia, well past the point where the Legacy was supposed to descend. So why hadn't the Legacy followed its flight plan?
The flight plan calls for you to descend to 360 at Brasilia. Why didn't you?
We weren't told to. Before we took off, we were cleared for 370 all the way to Manaus. That's what we did, sir. I don't know where you're getting the information from. Yeah, we followed the rules.
We were not told to descend, and we did not descend.
Colonel Ferreira needs to check the story that the crew is telling. He wants to know exactly what they were told by controllers when they took off from São José dos Campos.
November 600 X-ray Lima, ATC permission for Manaus, flight level 370.
The Legacy's last instruction was to fly all the way to Manaus at 37,000 feet. The pilots obeyed that instruction even though it differed from their flight plan.
Air traffic control always can deviate from the flight plan because they have best knowledge of the actual traffic situation.
Leaving Manaus, the Gol jet was also cleared to fly at 37,000 feet. Both planes were assigned the same altitude by controllers at opposite ends of the country.
Once we were certain that both planes were flying at the same altitude, we knew for sure there would be a lot to investigate on the side of air traffic control.
Ferreira turns his attention to conversations between controllers in Brasilia and the Legacy jet. The cockpit voice recorder from the Legacy gives investigators a remarkably detailed look into what happened on the private jet. The brand new Legacy jet has a state-of-the-art recorder that captures 2 hours of conversation.
The CVR was probably the most important component in the investigation.
November 600 X-ray.
At 10 minutes to 4, the crew is told to change radio frequencies and get in touch with the controller monitoring their flight.
Change frequency to 125050.
Decimal 1, I'm sorry, 12505, good day.
Good day.
At this point, the Legacy jet is approaching Brasilia, but the crew never receives any instructions regarding their altitude.
Brasilia, November 600 X-ray Lima, level 370, good afternoon.
November 600 X-ray Lima.
When the Legacy overflew Brasilia at flight level 370, according to the flight plan, it should have been descending to 360, but air traffic controllers simply forgot to give the order to the Legacy to descend to 360.
The pilots would have assumed they were meant to stay at 370, 37,000 feet.
No airplane should ever change altitude without receiving instructions from air traffic control.
To discover why controllers didn't give that crucial instruction, Colonel Ferreira takes a closer look at the technology used to monitor the traffic over Brazil.
So, can you call up the Legacy jet screen for us?
Na tela radar, nós recebemos a informação
On
de
the radar
velocidade,
screen, we see the altitude, speed,
e o
and the transponder
transponder, que é o
information of each
módulo
plane.
alfa, que nós chamamos, que é o código transponder da aeronave para a identificação de cada aeronave.
Each flight has an individual code assigned to it that helps controllers track it. Underneath that, there are 2 separate numbers. On the left, the plane's actual altitude. On the right, the altitude the plane is supposed to be at according to its flight plan.
So here, the number changes to 360.
As the Legacy jet passed over Brasilia, the number on the right, the planned altitude, changed. The computerized system automatically updated it. According to the flight plan, at this point, the plane was supposed to descend to 36,000 feet, 360.
To my knowledge, only Brazilian air traffic control system is using this kind of design. In other parts of the world, this update has to be done manually.
The computer changed a single number, which led to a critical error. Without much experience with the computerized system, the controller mistook the new planned altitude for the plane's actual altitude.
Só que o sistema mudou automaticamente, mudando o nível autorizado para
The
nível
system changed it automatically
solicitado.
from the
E aí o
authorized
controlador
altitude
acabou
to the planned altitude, which made the controller believe the Legacy was flying at
E quando
360.
o outro controlador veio assumir o serviço, ele passou para ele o nível que estava no plano de voo 360.
Police investigators talk with the controller who was on duty when the number changed on the screen.
It was shortly after that I went on break. Lucivando relieved me.
He tells police about a critical mistake on his part.
You have 5 aircraft. The Legacy is at 360.
Before leaving, he handed his flights off to another controller, telling him where he thought the Legacy was flying.
I believe it was at 360, and that's what I told you.
When the new controller took over, the one being relieved gave him the Legacy's altitude information according to the flight plan, 360.
But the jet was actually flying 1,000 feet higher, right in the path of the goal flight. Colonel Ferreira studies transcripts of conversations on board the Legacy and finds that the crew was having their own difficulties during the flight.
How much longer, guys?
That's a good question, Ralph.
The crew seems unfamiliar with some of the jet's advanced systems.
Still working out the kinks on how to work this flight management system. Where's the one that gives us total time?
My impression is that the pilots were trying to learn their aircraft systems during the flight.
Investigators also uncover a breakdown in communications.
Brasilia, November 600 X-ray Lima, flight level 370, good afternoon.
November 600 X-ray Lima. Squawk again.
After a brief conversation between the Legacy Jet and Brasilia
November
ACC,
600
Colonel
X-ray
Ferreira
Lima,
notices
squawk
something
again.
extremely unusual.
Radar surveillance. Radar surveillance.
For almost an hour, the Legacy pilots don't talk to anyone on the ground.
They stayed 57 minutes without attempting any contact with air traffic control, which seems like a lot of time. After 57 minutes, they tried to call 12 times without success.
minutos, realizaram inicialmente 12 tentativas de chamada, sem sucesso.
Brasilia, November 600 X-ray Lima.
Palladino did try to get hold of ground control, but he couldn't get through.
Brasilia, November 600 X-ray Lima.
He then tried the backup frequencies listed on his navigation charts.
Brasilia, November 600 X-ray Lima.
November 600 X-ray Lima.
His only contact, a single garbled message.
6.5.
Sorry, say frequency one more time for November 600 X-ray Lima.
Both pilots and air traffic controller should have been more concerned of maintaining two-way contact all the time. This is their duty.
Brasilia, November 600 X-ray Lima.
Had pilots and controllers spoken, they might have discovered that the Legacy was flying north in a corridor reserved for southbound traffic. As the public learns about the mistakes in the Air Traffic Control Center, there is growing pressure to make some changes.
We wanted to understand what had happened to these people inside the control room. The controllers should have been able to see on their radar screens that these two airplanes were flying in a collision course.
Brazilian air traffic control is one of the last in the world to be run largely by the country's military.
Since they're run by the military, they're run by the Brazilian Air Force, we did not have complete access to information except for what was released.
As fingers are pointed at controllers, many of them come forward with stories of overwork and poor training.
They complained that they weren't well trained in English language, which is the international aviation language. Also, they had complaints about their equipment.
In fact, the controller who incorrectly reported the Legacy's altitude had been on the job for only a year. A valuable piece of the puzzle is still missing. Investigators still don't know what happened during the final minutes of the GOL flight. Soldiers have been scouring the Amazon jungle with metal detectors looking for the plane's missing memory module. Almost a month after the crash, they find it. Colonel Ferreira hopes to hear some reason why the GOL crew wasn't able to avoid colliding with an oncoming jet.
GOL 1907. Contact Brasilia, ACC on 125.2. A good flight.
Thanks very much, Brasilia 12.2. GOL 1907.
There are no alarms before the collision. No warning that they were flying straight for another jet. Pilots rely on air traffic controllers to keep other planes out of their path. They spend much of their time monitoring their instruments, not the skies ahead. At the speed they're traveling, they'd only have to look away for a few seconds to miss an approaching plane.
There were no issues of communication and no misunderstanding between the pilots and air traffic control. They had no idea what had just happened to their plane and fought until the end to regain control.
For less than a minute, the pilots struggle for control, but there's nothing they can do. But why were there no warnings? Both planes were equipped with a safety feature designed to prevent exactly this type of accident. Ferreira now needs to know why that system failed. Earlier in the investigation, strange radar images suggested that the Legacy pilots were flying wildly over the Amazon. Now those suspicions have vanished, but Ferreira revisits the fluctuating radar data to understand why neither plane knew the other was coming.
You see, the altitude is varying significantly.
To try to understand this last piece of the puzzle, Colonel Ferreira returns to the radar display that air traffic controllers saw the day of the crash. Instead of displaying just the expected altitude and the actual altitude, the letter Z appears between them.
The Z on the air traffic controller screens indicates that the airplane he's looking at has lost its transponder.
Modern commercial aircraft are equipped with transponders. Like small radio stations, they broadcast information on the plane's altitude and flight number. This information is received by computers on the ground and instantly displayed on the screens of air traffic controllers. In Brasilia, if the transponder fails, so-called primary radar takes over automatically. Signals are sent out from the ground that hit the target and return. Those readings are wildly inaccurate.
Primary radar only is a passive indication of anything that is flying through the airspace. The difference of the actual altitude in the primary radar system might differ several thousand feet.
The inaccuracy of the radar tracking the Legacy jet explains why its altitude appeared to be rising and falling. Investigators discover that the transponder wasn't sending out signals for more than 50 minutes before the crash. But controllers didn't notify the pilots. That may be because they didn't notice the subtle change.
A forma como é apresentado para o controlador não é nenhum sinal de alerta. Não existe algo que chame a atenção visual para o controlador, como se piscasse ou algo que chamasse realmente a atenção do controlador para que, naquele momento, aquela aeronave perdeu.
There's an even more critical role played by the transponder. It doesn't just beam information to controllers on the ground, but to other planes as well. All commercial aircraft are equipped with a warning system called TCAS, the Traffic Collision Avoidance System.
TCAS gives a relative position of other airplanes within range of your own airplane.
TCAS picks up a signal from an oncoming plane's transponder and issues a warning if it's too close. If either plane's transponder is off, the system won't work.
What the hell is that?
Ferreira discovers that the Legacy's transponder was working early in the flight and after the collision. But for more than 50 critical minutes, it was silent. How had a state-of-the-art jet, just off the factory floor, developed problems with its transponder?
Parada de funcionamento de transmissão do transponder.
The failure of the transponder certainly contributed to this accident.
Para a ocorrência do acidente. E nós tínhamos
and we had to find out what caused it to fail.
Descobrir o que causou essa interrupção no funcionamento.
Investigators examine the Legacy jet's transponder unit. They discover that the system which controls it had a troubled history. It had been installed on a different plane, but removed because it wasn't working. It was repaired and then placed on the jet that was sold to XLR. Investigators have the system tested. But even with its suspicious past, after the crash they can find no obvious problems with the plane's transponder.
Now this is the layout now on the standard one in the Legacy jet.
Colonel Ferreira does notice something potentially dangerous about the design of the Legacy's cockpit. If a pilot uses the built-in footrest during flight, his toes can come in contact with the buttons on the transponder.
Here, show me what it looks like in standby mode.
And when the transponder does go into standby, it would be difficult for a pilot to notice.
There's no alarm?
A small yellow warning light is the only indication that the transponder isn't on.
It was not easy for the pilots to detect that because it's not hooked up with the central warning and alert system.
But the pilots of the Legacy jet do not remember using the plane's footrest.
Still working out the kinks on how to work this flight management system. Time.
Investigators suspect that one of the pilots may have turned the transponder off by mistake.
No momento, o cenário, mas o cenário provável.
The most probable scenario is that by accident, one of the pilots temporarily turned off the equipment as he tried to familiarize himself with the technology on board.
However, the transponder went off. At a critical moment, the crew had no last-ditch safety system to warn them that they were flying right at a 737. Even though the TCAS system on the GOL plane was working, there was no signal from the approaching jet for it to receive. Closing in on each other at 1,600 kilometers an hour, the pilots never saw each other coming. Brazil's air traffic control system would undergo some radical changes as a result of the collision. But those changes would not come without a fight. The investigation into the crash of GOL Flight 1907 has uncovered dangerous problems with Brazil's air traffic control system.
Brasilia, November 600 X-ray Lima, level 370, good afternoon.
Two planes were assigned to fly at the same altitude in the same airspace.
Radar surveillance.
Overworked and inexperienced controllers in Brasilia neglected to instruct the Legacy jet to descend to 36,000 feet.
You have 5 aircraft. The Legacy is at 367.
Then they mistook the Legacy's planned altitude for its actual altitude. To make matters worse, the Legacy pilots, unfamiliar with Brazilian airspace, were unable to make contact with controllers on the ground. And somehow the transponder, which broadcasts their location in the sky, went silent, which controllers in Brasilia failed to notice.
Keep going!
A multi-billion-dollar ATC system designed to keep planes apart had failed to detect two planes on a collision course.
Uma série de erros, de falhas humanas ocorreram e onde as defesas,
one by one, a series of human errors occurred, and all of the defense systems that exist to avoid these errors were
para
defeated.
evitar esses erros foram sendo uma a uma vencidas.
A month after the crash of the GOL passenger plane, controllers begin a work to rule campaign. They want to draw attention to problems with the system.
Once they did start working to the rules and not stretching them anymore, this triggered what we called the aviation crisis in Brazil. At a certain point, maybe 40% of flights in all of Brazil had over an hour delays.
Following the crash and the work slowdown, changes start being made.
There has been a lot of changes in Brazilian aviation after the accident, specifically with regards to air traffic control. The Air Force had to admit that they had a shortage of controllers, and also there's a higher degree of accountability.
In the United States, the Federal Aviation Administration issues two recommendations as a result of the tragedy. Pilots flying Legacy jets are warned of the possibility that putting their feet up in the cockpit could accidentally turn off the transponder. And manufacturers are told that an alarm should sound if the TCAS system shuts off. The controllers who were involved in the crash are charged with varying degrees of manslaughter. But those criminal charges worry people who were closely involved with the disaster.
Trabalhar uma investigação com fins de prevenção, quando existe uma
An
pressão muito
investigation like
grande
ours, which
de
focuses
outros
on
processos
prevention,
criminais
suffers huge setbacks when there is
oriundos
pressure
de
to lay
uma
charges.
comoção muito grande por ter sido o maior acidente.
By blaming people, we might be creating a culture where people will not come forth and be honest about failures and mistakes. And when we try to hide that, things get swept under the carpet, and soon enough they'll come out again.
Nenhum controlador sai de casa hoje
No controller
pensando que
leaves his
vai
home in the
bater no
morning
avião
thinking
ou
he's
ele
going to
quebra
crash a
o avião.
plane.
Então,
And so the
a criminalização
criminalization
só
only
atrapalha a
interferes with
investigação
investigations that
que
can
pode,
prevent
no
further
futuro pode vir
accidents.
a evitar novos acidentes.
More than 2 months after the crash, the crew of the Legacy jet is finally allowed to return to the United States.
Joe and Jan barely got out of the country. There was an attempt to hold them under what I thought was a cobbled together initial criminal charge of, quote, failing to ensure the safety of Brazilian skies.
While we are all grateful for the safe return of Joe and Jan and everyone aboard the Legacy, we are all saddened by this tragedy which took many innocent lives.
More than a year after the accident, the Legacy jet that survived a mid-air collision was still at the airfield in the Amazon. Its maiden voyage cut short by a tragic series of technological and human errors. Just minutes from Strasbourg Airport, an Airbus A320 slams into a mountaintop.
Delta Alpha, your position?
There are survivors.
And I'll panic because I'm going to burn.
But they are still in grave danger. It's bitterly cold, and what they don't realize is that no one knows where they are.
They could be anywhere in there.
Expect this in the jungle or the rainforest, but not in a highly populated area.
Before investigators can begin searching for what caused the crash of Air Inter Flight 148, they must first find the plane. January the 20th, 1992. Air Inter Flight 148 has departed from Lyon, France.
124.905, thank you.
Captain Christian Hequet and First Officer Joël Charubin are experienced pilots with over 12,000 hours of flying time between them. The flight is a short hop between Lyon in central France and the city of Strasbourg in the mountainous Alsace region. The French airline Air Inter caters mostly to business travelers and prides itself on being timely. Crews are motivated to avoid delays, as former Air Inter pilot Gérard Arnoux explains.
We were famous for a very short turnaround. And the faster we flew, the better wages we got.
Have we been flying for 35 minutes yet?
41 minutes.
The crew is flying an Airbus A320, one of the most technologically advanced commercial airplanes in the world. Even before takeoff, The pilots programmed the autopilot to land on a specific runway in Strasbourg. The cockpit of the A320 is also very different from other planes. Instead of analog gauges, the pilots look mostly at digital displays.
Strasbourg, good evening. Runway News 05. Transition level 50. Wind 040 at 18 knots. Visibility 10 kilometers.
A recording from Strasbourg Airport informs the crew of a change in plan. Due to high winds and poor winter weather, they'll have to land on an alternate runway.
05 in service.
Not the one programmed into the autopilot.
05. What sort of wind are they giving us?
18 knots.
18 knots.
Captain Hecke doesn't like the idea of changing runways.
No chance.
He was hoping to use runway 23, an approach that provides the autopilot with a precise navigational fix. The new runway, runway 05, is surrounded by mountainous terrain that can interrupt radio signals sent to the autopilot.
You know, if we go with the runway 05 procedure, we... Oh, no.
Captain Hecke suggests a compromise.
I'm putting back runway 23. Otherwise, I couldn't make the ILS interception.
He'll program the autopilot to fly towards runway 23. But near the airport, the captain will take over the controls and make a visual landing on runway 05.
You're taking 23 then?
Yes!
Ladies and gentlemen, we are commencing our descent. We ask you to please return to your seats.
Nicholas Skorias is a university graduate student.
It was a quiet day. I was expecting to go to see my girlfriend in Strasbourg, so I was very happy.
Roger 854, proceed to GTQ air level 140, contact Reims. Delta Alpha, Strasbourg.
Yes, we intend to proceed to do an ILS on runway 23, then an indirect for runway 05 after that.
The Strasbourg controller considers the captain's plan.
Delta Alpha.
He warns that there will likely be a delay due to heavy traffic.
Given that we're going to have 3 takeoffs on 05, you risk waiting in a stack at 5,000 feet.
We're not going to mess about like that, descending at full speed. If they had warned us in advance, cripes!
Delta Alpha, Strasbourg.
I hear you.
Aware of the captain's frustration, the controller offers assistance.
If you want, I can take you with the radar to lead you to Andlo at 5,000.
Andlo is a navigational point on the approach to runway 05. It helps pilots align the plane for landing.
Yeah, that's good.
Oh, yeah. Okay, then, turn left to heading 230 degrees.
148.
Turn left to heading 230 degrees.
There you are. That will save you some time.
Since runway 05 doesn't allow for a full autopilot approach, the captain must calculate the angle of descent on his own.
That makes 3.3 degrees.
Donc 3,3, c'est tout à fait normal, oui.
3.3 degrees is a normal flight angle that provides a good slope for landing.
Doucement, la bonne pente, voilà.
Ladies and gentlemen, we are continuing our descent.
The flight from Lyon to Strasbourg was quite short. I think 50 or 45 minutes. Nothing special. It was very natural and very ordinary.
Thank you.
Turn left, steer 90. 090 degrees, Delta Alpha.
The controller talks Flight 148 through the last turn to align the plane with the runway, now 25 kilometers away. Then, First Officer Cherubin notices the plane is slightly off course.
We're headed inside. You're inside there. You should have started with 070.
Yeah.
At least that much.
The controller also notices that the plane is off course.
Air Inter, Delta Alpha.
It has missed aligning itself with ANDLO, the runway's electronic guidepost.
Delta Alpha, you're passing to the right of Anlo.
Nevertheless, he authorizes the landing.
Authorized for final approach 05.
Delta Alpha.
The captain initiates the landing sequence.
Flaps towards 2.
Flaps towards 2. Flaps at 2.
Gear down.
Ladies and gentlemen, we are going to land in a few minutes.
Heke notices that the plane is traveling too fast, so he extends the speed brakes. They disrupt airflow over the wing, which helps create more drag to slow the plane.
We have to watch our descent.
The approach axis.
The first officer is more concerned with their horizontal position in relation to the runway.
It was 60. Check it out.
Wait.
But before the crew can adjust their course,
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
the crash is catastrophic. The A320 has flown into the side of a mountain.
Delta Alpha, your position?
Flight 148 is no longer on radar, nor responding to radio contact. An emergency is declared at Strasbourg Airport.
This is the last hit we got. We were flying about 20 kilometers away from the airport.
Officials need to pinpoint the crash site, but it's not as easy as it might seem. The airport's radar is not recorded. There has been no signal from the plane's emergency beacon, and surprisingly, no one has reported seeing a plane go down.
It could be anywhere in here.
The proposed search area covers more than 20 square kilometers of dense forest just outside Strasbourg. Nicolas Scaria survives the crash of Air Inter Flight 148 with only minor injuries.
I took off my seatbelt, I get up, I tried to find my suitcase in the lockers, but there wasn't any lockers. I realized that I was alive. It was a crash. I saw a fire in front of me, and I panicked because I said to myself, I'm going to burn. I went to the back of the plane, of what remained of the plane. I found some other survivors.
Come on! It's gonna blow!
I was afraid of the explosion. I was panicked.
With the smell of leaking jet fuel in the air, the survivors move away from the burning plane.
We stayed together, waiting for the first aid.
But the wait will be longer than anyone might expect.
The first reaction that we have after the crash was, okay, in half an hour, 1 hour, most, and the worst, okay, the rescue team will be here. And it wasn't here.
1 hour after the crash, rescuers still have no idea where the wreckage lies. Skouras and the others now face a new ordeal. Surviving sub-zero temperatures in a dark and isolated forest. 2.5 hours after Flight 148 disappeared from radar near Strasbourg Airport, the missing plane has still not been located. Amidst growing tension, the French Aviation Bureau, the BEA, sends in its lead investigator, Jean Pariès.
I immediately called my two main investigators, and we organized the GO team, and we got prepared to rush to the site as soon as this site was located somewhere.
The delay feels like an eternity.
A little bit surprisingly long. We can expect this in the jungle or the rainforest, but not exactly in a highly dense populated area like the Strasbourg area.
With no help in sight, Skouras returns to the wreckage to look for more survivors.
I think that some people that die could have survived if the first aid come sooner.
Nearly 1,000 people search for the missing plane. But 3 hours after the crash, there's still no sign of it. Frustrated, Skouras goes looking for help. He stumbles into a TV crew trying to find the crash. But with no wreckage in sight, they react with skepticism.
They didn't expect survivors from an airplane crash.
Hey, you have to believe me!
They didn't believe that I was one of the survivors, but believe me, I was, because my face was black due to the smoke, the kerosene, and so on.
Come on!
The journalists follow him back to the crash site, where they discover 8 other survivors. Finally, the first rescuers arrive. The crash site is located near the top of the 2,500-foot Mont Saint-Odile, 19 kilometers from the runway.
They found us after 4 hours and 30 minutes. So it was a mess. I was very, very disappointed that at 20 kilometers from Strasbourg, and they couldn't find us.
A total of 87 passengers and crew have died, including the pilot and co-pilot. The survivors begin to tell their stories, but no one reports anything that might explain why the plane crashed.
I don't know what happened. We were landing. I lost all consciousness. We must have hit the trees.
Bob McIntosh, an American NTSB investigator, arrives at the crash site.
The BEA of France recognized the international attention would be on this accident, even though it was a domestic accident. He invited a group of international accident investigators to come and participate.
Welcome to the team.
The first priority for investigators is to retrieve the plane's black boxes.
We have not removed the recorders yet. Good.
With the boxes trapped in the burning tail section, any delay could prove costly.
We're very anxious about the state of the tape inside. Will it be possible to use it? Will we get the critical information we need?
In France, aviation accidents are also investigated by the justice system. Pariès and his team are not allowed access to the site until judicial officials secure the black boxes.
I had a visual picture of the gendarme, transport police standing around keeping us away from the wreckage for a while. And we're very suspicious of these international observers.
Maybe we should wait.
Even taking photographs, which was somewhat surprising to us.
In a previous crash, the crash of Air France Flight 296 in 1988, investigators waited 10 days before turning the black boxes over to police. Rumors persisted that these boxes had been tampered with. This time, police are keeping investigators at bay.
I can recall seeing the glowing embers and seeing the flight recorder sitting there and not being able to intervene and say, get that thing cooled down as soon as you can.
After midnight, the boxes are retrieved from the plane and sent for analysis. Investigators can only hope it's not too late.
They was extremely hot. They looked damaged, they looked burned.
In the light of day, investigators get some of their first clues from the crash site itself. They discover why the plane's emergency locator beacon didn't send a signal.
It was actually destroyed by the impact.
The beacon is located inside the cockpit and is designed to start working after a crash. Its failure suggests an unusually forceful impact with the ground.
We had this first feeling that the descent was abnormally steep.
Investigators examine the engines to see if they may have stalled before impact.
If you find the blades curved and a lot of wood sucked inside the engines, then you understand that the engines were working properly.
And that's exactly what they find. The plane clearly had power, yet it plowed steeply into a mountainside without ever sending out a distress signal. Investigators are puzzled. They hope that the box which recorded the plane's flight data will help them solve the mystery.
Those particular recorders had the best survival record of any recorders. They were the top of the line as far as survivability is concerned.
The black box is designed to survive temperatures up to 1100 degrees Celsius for half an hour. The tape recorder inside is protected by a capsule filled with water.
When the recorder heats up, the water turns to steam, absorbing the energy, and actually vents out through a little hole in the crash enclosure.
But when the flight data recorder is opened, investigators make a troubling discovery.
The FDR was totally damaged, impossible to read anything from it.
It was subjected to heat beyond the 30 minutes. The recorder was just never designed to withstand that kind of sustained heat.
And so we were very disappointed.
There's now only one hope for recovering the plane's flight data, a device called a Quick Access Recorder, or QAR. Maintenance workers use the QAR to access the plane's computers, but it also records some flight data. Unlike the black boxes, the QAR is stored near the cockpit.
Quick access recorders are not protected at all. They're up in the front end of the aircraft, typically in the electronics bay. They're generally destroyed just from the impact damage.
Investigators are encouraged to discover that in this case, the QAR has survived. But on closer examination, their optimism turns to frustration.
The last 20 centimeters of the tape were burned and stretched and were damaged to the point that we could not use them into a machine. We couldn't read it.
Investigators are desperate to retrieve the data, so they take a chance on an experimental technique. Known as the garnet technique, a light is shone through a mineral lens made of garnet.
Use a garnet stone to visualize the magnetic pulses that are actually recorded on the tape.
The special lens helps the technicians differentiate between the positive and negative magnetic pulses, which translate as binary digits, or bits.
There's 768 bits per second, so that's a lot of ones and zeros. You have to be very precise in moving the tape under the lens or the garnet to make sure you don't miss a bit or read the same bit twice, you know? So it's difficult.
Analyzing the data is even more painstaking.
It took about a day to read a second of recording. Any additional second recovered could reveal something that would make a difference.
The effort to retrieve all the QAR data could take a month or more. In the meantime, the focus of the investigation shifts to the cockpit voice recorder. It was positioned just above the other black box.
The cockpit voice recorder, which was just inches away, but outside of the ashes, had air passing over it, survived.
Runway 23. Otherwise...
The recording reveals the captain's anxiety early on in the flight.
You're taking 23 then?
Yes!
Investigators know that landing on runway 05 requires what's called a non-precision approach. That means pilots receive electronic guidance only on their horizontal position, left and right. They get no guidance when it comes to altitude.
The non-precision approach is significantly less accurate. Why, it's not really difficult, but they are less comfortable.
05. What sort of wind are they giving us?
The non-precision approach increases the demands on the pilots. Investigators can also hear that the captain had concerns about landing on runway 05.
48 Delta Alpha, you are number 1 with QAR DME runway 05.
Runway 05.
10 nautical. That won't work.
It's a lot of distress over a non-precision approach.
Wondering what can cause such distress, investigators research pilot training at Air Inter. They find that most pilots did not have extensive training making non-precision landings in the new A320.
I think we should have had double the training compared to an older plane.
Investigators ask the airline for detailed records on the pilot's history of runway approaches. They're intrigued by what they discover. Captain Heke had landed at Strasbourg countless times, but he had never landed an A320 there using a non-precision approach.
We're not going to mess around like that descending at full speed.
Clearly, the captain was uneasy about having to execute a landing he had never made before.
I think the captain was worried about making it in a minimum amount of time, and the minimum amount of delay.
Have we been flying for 35 minutes yet?
And the co-pilot was worried about not getting in trouble by offending the captain.
At least that much.
More research into the pilot's work history offers yet another revelation. While the two pilots had flown more than 12,000 hours between them, they were both still relatively new to the highly advanced A320.
It's 05 in service.
The aviation community misunderstood the magnitude of changes brought by the new Airbus A320.
The captain had only 162 hours in the A320, and the co-pilot even less, just 61 hours.
Behind this accident scenario, there is an issue of confidence of the crew in themselves, in the aircraft.
18 knots. No chance.
They were not prepared, really, to fly in this kind of condition.
If they had warned us in advance, cripes!
Investigators conclude that the crew's training was insufficient. But that alone does not explain the crash.
Merde!
Investigators search for other factors in the crash of Flight 148. They review the conversations between the crew and air traffic controllers.
If you want, I can give you radar headings and take you to Anlo at 5,000.
Yeah, that's good.
The radar vector makes flying easier. The captain was happy because it was reducing his workload.
Turn left, steer 90.
With the controller's assistance, this landing should have been very simple. But when investigators reconstruct the plane's trajectory using radar information from various stations around the airport, they discover a shocking error.
The 090 heading started here.
090, 0 degrees, Delta Alpha.
But it won't take them to Andlo. Last radar vector the controller gave was incorrect. It sent them...
Thank you.
...closer to the mountain.
They were, of course, because of following the heading they got from the radar vectoring, they found themselves in this undershoot situation.
You're inside there. You should have started with 070.
Yeah.
Investigators are also troubled by the controller's choice of words when he warned the pilots, incorrectly, that they were headed to the right.
Delta Alpha, you're passing to the right of Anlo.
From the pilot's perspective, the plane was on the left side of the runway, not the right. It could only add to their confusion.
Le contrôleur, en fait, il a fait un...
It was very poor guidance because he didn't employ the usual terminology.
Et il n'a pas utilisé la phraséologie standard.
Investigators recommend that controllers use only compass points when giving directions. Never the words right and left. The controller's mistakes clearly brought the plane closer to the mountain.
Turn left, steer 90. 090.
But once again, investigators feel they don't have the whole story.
It's not something totally abnormal to start a descent from this situation.
Flaps towards 2.
Flaps towards 2.
It's not what you expected to do every day, but it's not outside the tolerance of the concept of this approach.
Gear down.
When investigators study the plane's reconstructed flight path, they discover something more alarming than the plane's horizontal misdirection. As it circled the mountain, the plane inexplicably entered a dangerously steep and rapid descent.
Perhaps 2.5 times the normal rate of descent.
That's lethal at that altitude.
Without the steep descent, they would have cleared the mountain.
If the vertical trajectory had been correct, they would have no problem at all.
Finding the cause of that sudden descent is now key to understanding why 87 people died in one of the most advanced passenger planes on Earth.
Authorized for final approach 05.
The descent was initiated at 1800 hours, 19 minutes and 38 seconds. That
Delta Alpha
is the point of no return.
By studying Flight 148's trajectory, investigators determined that the rapid descent began 60 seconds before the crash.
Delta Alpha.
There is no indication on tape that the descent was deliberate. How it happened and why the crew didn't notice is a mystery.
It should be a no-brainer. Keep track of the altitude.
The cockpit altimeter gives pilots a constant readout of their altitude.
Altimeter, that's a very precise instrument. They become very reliable. They're accurate to within 5 or 10 feet.
Ignoring it would be a major error in flying protocol.
Flaps towards 2.
The recording reveals just one single remark from the crew about their descent.
We have to watch our descent.
It occurred 16 seconds before the crash. The captain had just extended the speed brakes.
The aircraft was accelerating abnormally. The captain started to realize there was something wrong with the descent rate.
But the first officer changed the subject.
The approach axis. We're hitting the axis a half point off.
There. It was 60. Check it out.
He refocused the captain's attention on the lateral situation rather than the vertical situation, which was the main problem, of course. And they both failed to recognize this situation.
I think they were planning that we're going to break out of the clouds so they'd be able to see the runway, and they wouldn't need to do the full instrument approach.
It was 60. Check it.
But the plane never left the clouds.
There's an old adage in aviation. Rocks have been known to hide out in those clouds.
It now seems clear that the crew was not monitoring their altitude closely enough. But a bigger mystery remains.
We can only guess why.
What caused that deadly descent? After months of work, investigators may finally have the answer. All the available flight data from the damaged quick access recorder has been recovered.
We were very anxious to be able to read as much as we could.
The data confirms that just before the crash, the plane was speeding towards the ground at an extremely high rate, 3,300 feet per minute. It also confirms that the angle of descent was dangerously steep, much greater than the 3.3 degrees selected by the captain.
3 degrees.
That's quite a difference.
Investigators now wonder, did the autopilot malfunction? Did it somehow fail to obey the captain's safe descent angle and send the plane into a deadly nosedive?
But what state was it in before the accident?
Unfortunately, the flight control unit which houses the autopilot is too badly damaged to provide any definitive answers.
We could never demonstrate that this FCU on this aircraft during this flight functioned properly or not.
But then, when he returns to studying the flight data, Paris discovers something that may finally reveal the cause of the crash. He notices a similarity between two key numbers: the plane's vertical speed, 3,300 feet per minute, and the intended flight path angle, 3.3 degrees.
Coincidence?
Paris uses a flight simulator to test a new theory.
Can you show me a descent of 3,300 feet per minute?
He believes that the similarity is no mere coincidence. On the autopilot, there are two descent modes: flight path angle and vertical speed. But they are both displayed on the same window. So 3,300 is abbreviated to 33.
Now, show me a flight angle of minus 3.3 degrees.
And the problem on this aircraft was that the two values were visible on the same window and controlled by the same knob.
3.3 degrees.
Minus 3.3 degrees.
Paris strongly suspects that the confusing display tripped up Captain Hecquet.
So it wouldn't be hard to make that mistake, would it?
The confusion is quite easy between the two modes if you don't do it carefully.
If the captain failed to push the mode selector knob, then entering 33 would not have initiated a safe 3.3 degree angle of descent. Instead, it would have put the plane into a deadly rate of descent of 3,300 feet per minute. Two months after the crash, another Air Inter plane enters a dangerously steep descent for the same reason.
The crew only discovered the problem when they broke out of the clouds.
Those pilots also confused the plane's flight path angle with its vertical speed.
They were lucky enough to have a much higher cloud base so they could correct the problem.
Further research reveals an industry-wide problem with the A320.
Many people confuse these modes, especially during training, and many of them fell in the trap even after the training.
Eager to test his new theory, Jean Paris programs a simulator with all the known data from Flight 148.
Okay.
He then inputs the same rate of descent he believes the Air Inter pilots selected. If Paris is correct, The simulation will end with the plane hitting the mountain. But it doesn't.
We're missing something.
Strangely, this didn't lead to a crash. Every approach would overfly this obstacle by significant margins.
Have we factored in the wind?
We started to work on other alternate hypotheses.
Let's try again, but initiate the turn sooner.
But nothing was really credible.
No matter how hard he tries, Paris cannot simulate the crash. Unable to explain why, he turns to the plane's manufacturer for help.
Thanks for bringing this to my
After
attention.
much research, an Airbus designer comes to Paris with an explanation about a little-known element of the Autopilot's design. In emergency situations where the A320 needs to change direction quickly, the Autopilot is programmed to reverse the plane's direction at twice the normal rate.
The reaction of the Autopilot would be much faster. And these cases were typically when you were descending and asking the Autopilot to climb, or climbing and asking the Autopilot to descend. We immediately went back to the data at the very second at which the descent was commanded by the crew.
Gear down.
Paris discovers a tragic coincidence.
Sadly, we found that at this very second, there was turbulence.
There was an ascent. It's very slight, but there it is.
The momentary turbulence caused the plane to climb slightly.
And this led to a positive 600 feet per minute vertical speed for maybe half a second.
It was during that same half second that the crew commanded the plane to descend.
It was 60, check it out.
The Autopilot read this as an emergency requiring a blazingly fast descent.
That could be it.
Investigators now contemplate a terrible thought. Could a random gust of wind, hitting at exactly the wrong split second, have been the difference between life and death?
Here it comes.
And we got a crash.
Paris's theory explains every aspect of the crash. The crew's confusion with the Autopilot display
3.3 degrees.
caused the plane to descend dangerously close to the mountain. Turbulence and an obscure safety feature brought it even closer. It was a fatal combination.
It's a fascinating lesson about the random dimension of accidents. Half a second before, half a second later, they wouldn't have the accident.
The discovery of a confusing cockpit display has enormous implications for the entire industry.
The flight instrumentation of aircraft like the DC-10, MD-11s, the 747s and so on, all the Boeing products and all the commuter products that were using that avionics suite had this vulnerability about it.
Investigators now face a daunting question affecting aircraft safety around the world. If the design of the Autopilot interface isn't changed, how many more people could die? There's mounting evidence that the design of the Autopilot interface on Airbus A320s led the Air Inter pilots to accidentally dial in a dangerous rate of descent.
3.3 degrees.
We felt a need to start the industry to work on this.
The plane's manufacturer, Airbus, responds immediately.
The main change, which was very quickly made, was to change the display window.
With the new design, if a pilot selects a vertical speed of 3,300, the entire 4-digit number is displayed.
So the confusion between an angle and a vertical speed was no longer possible.
For investigators, only one mystery remains. All Airbus A320 jets are designed to be equipped with a safety device known as a Ground Proximity Warning System, or GPWS.
which is a downward-looking single-purpose radar that tells you how high you are above the ground directly beneath the airplane. And if it gets to be too low, it'll set off a warning.
Pull up, terrain. Pull up.
But Captain Hackey
We have to watch our descent.
never received a warning for one very simple reason. His A320 didn't have that alarm.
The first question, of course, was why the aircraft was not equipped.
So it's not part of the minimum equipment list.
The Air and Terror Management had decided they did not like the false warnings that had been produced by GPWS equipment.
Normally, most planes fly slower than 250 knots when under 10,000 feet, but we flew at 350 knots until the final approach. So at those speeds, GPWS was always giving off false alarms.
Dans ces conditions, parce qu'il générait des fausses alarmes.
This decision, while legal, prevented the pilots from having one last line of defense before crashing into the mountain.
C'est pas possible d'imaginer un instant.
It's impossible to imagine that the pilot wouldn't have pulled up if he'd heard the alarm.
We should have a GPWS on commercial flights in any case, yes. That's an obvious conclusion.
The report will list these causes: flight deck aerodynamics.
Investigators conclude that there was no single cause for the crash of Flight 148.
Training, lack of GPWS.
The tragedy involved an ill-fated combination of many different weaknesses in the airline industry.
We made 35 or so recommendations, including pilot training, about the ground proximity warning system, and so on.
The recommendations lead to sweeping changes. Pilots must now have more A320 training before getting behind the controls.
Le pilote, je crois, qui est
One of the two pilots now need to have at least 300 hours on the plane. They estimated that 300 hours were enough.
parlait de 800, il parlait d'un niveau d'expertise.
Another change, the design of a more heat-resistant black box.
The FAA did a test, did some studies, what the thermal characteristics of post-crash fires were, came up with a value of 260 degrees C for 10 hours.
Delta Alpha, your position? Air Inter, Delta Alpha, Strasbourg.
As a result of the Strasbourg crash, the A320 is now a safer plane.
You can only get this change if there is what people perceive to be a good reason. And sadly, a good reason is still an accident.
But improved aviation technology is still no substitute for well-trained, well-prepared pilots.
There's an old axiom in aviation that you taught early on that never let an airplane take you somewhere that your brain hasn't visited at least 5 minutes ahead of time. This is an excellent example of a flight crew that didn't follow that particular axiom.